Thus far in this course and in the apps we built in this course, we only covered the scenario that we have essentially one page in our application. And of course, in most applications, you actually have more than one page, or screen as it's also called. You might have a user profile page, a page with all products. Then when you tap on a product, you see the details for that product on a separate screen. And you can navigate between these screens with the back button, by swiping back, or maybe you have some tabs at the bottom, or a drawer, which you can open with a hamburger icon in your top navigation bar. And that's exactly what we'll have a look at in this section. In detail, we'll have a look at what navigation and screens are, what these terms mean, and what they mean in Flutter apps, and how you can add navigation to Flutter apps. You'll learn about pushing and popping pages and what this means and how it works in Flutter. We'll have a look at adding tabs and drawers to an application so that you have different ways of switching between different areas of your app. And last but not least, a super important topic, of course, you will also learn how to pass data between your screens. So how you may, for example, pass the data about an selected item into the details screen that opened up for that icon. These are all things we'll have a look at in this module now. Throughout this module, we'll build this application here. This application where we can browse meals by category, mark them as favorites if we like them, set filters where we can decide which kind of meals we want to include, so that I now, for example, only include vegetarian meals like this one, gone is the toast and the burger. And we can of course also use tabs here to then, for example, see our favorites. Now, as you can already tell, you'll learn a lot about navigating around, going back and forth, using tabs, and using the side drawer, and even many things which you don't see here on first look. And as a side effect in this module, you also learn how to build a beautiful application with many new cool features and widgets which we haven't used thus far in the course. So let's plan the app we're going to build. In this app, well, that's the idea of this module, have more than just one screen. So in our app bar, for example, we'll have a hamburger icon, this one here, which allows us to go to different places of this app, because when we tap it, then we'll actually open that side drawer menu here. So we'll have a backdrop in front of the rest of the page. And then here we'll have a link, so to say, a button that takes us to the meals page, and one that takes us to the settings page. Now, the meals page is actually the default, which is loaded when our app starts, and we only have it in the side drawer so that we can go back there if we were on the settings page. But on the meals page, so on our starting page, we'll also have two tabs at the bottom. One basically for all meal categories, so all categories, and one for our favorite meals, which we marked as favorite, because we'll have the functionality in the app to mark a meal as our favorite. Now, in the all categories area, if that tab is selected here, we'll have a couple of category items here on that screen. So something like Italian or veggie and so on. So we'll have more of these items. And when we press one of these items here, then we are taken to a new screen. And in that screen, we'll simply list the recipes for that category. Now there, each recipe could be such a card with an image, a title, and some rough information about that recipe, like how complex it is and so on. So we'll basically have a list of these recipes here on this page, a scrollable list, of course. And when we then tap one of these recipes, we're taken to yet another page where we see the full details for this recipe. So we have the image maybe, and then we have the ingredients here, and then also the steps it takes to create that dish, that meal. So that's the general flow here for our recipes. Now, when we press the settings here were also taken to a separate page, of course. On this page, we'll have a couple of settings, like that we only want to see gluten-free meals. And for each setting, which we have here, we'll have a little switch here, which we can set to on or off, and that's really ugly, but these are switches where we can toggle these different filters, and the settings of these filters here, so the settings of these filters should of course affect which meals we see here when we are in the category page, so when we picked up category and we want to see the recipes here. Now we also of course have the favorite tab. So if the favorite tab here is selected, then we still are on this page with the drawer at the top and the tabs at the bottom, but well, now this favorites tab selected. And here we simply also have our recipes with the image and so on. So this list, which we also had over there, but now only the recipes or the meals, which we marked as a favorite, which we can do from inside that recipe detail page over there. So from inside this page here, we can mark recipes or meals as a favorite. So this is the overall app we're going to build. As you can see, we'll have a couple of different pages there, a couple of different screens which we need to connect and where we need to pass data back and forth. Like for example, the settings we picked here, the filters we picked here would have to be passed down to filter our recipes. And when we select a recipe or when we select a category, we need to pass that info off that category, for example, which was picked here, to that category screen, which shows the recipes for the category, and so on. So a more complex and therefore more realistic application. So let's now see which tools Flutter gives us to build such an app. Obviously, before we can start using the various tools for passing data around and so on, we need to build a couple of these screens which we need. So here I am in a blank project again, and you find this blank setup attached to this lecture here. It's an empty Flutter project, just has the default main Dart file, slightly edited. I changed the text in the app bar here, and right now if I start this application here on my Android emulator again, it will only have a centered text where I say navigation time. I also haven't added any specific theme here. I'm just going with the default settings of having a blue theme here, though these are all things which will adjust throughout this module. So we'll primarily, of course, work on making sure that we have navigation and so on, but we'll also, of course, make sure that we build a pretty application. So here's the dummy application. Pretty empty right now. And the thing I want to start with is that starting page which shows us various categories of meals, like Italian, veggie, and so on. And then the detail page for each category, which then in turn shows us the recipes for that category. That's the idea here. So in the code, I think it makes sense to start with that categories page where we see all the available categories, where we then can tap on one to see the meals, the dishes for that category. So it would make sense that this is our first new widget we add. And this will not only be a widget, it will also be a screen of our app. Now, technically, there is absolutely no difference between a screen and a widget. Every widget can be used as a screen. It only is a term that describes a widget which we use to control an entire page on our app, like the My Homepage widget, which we get out of the box. It controls the entire page we have here. Typically, any widget that uses scaffold is a page, as a screen widget. Again, not technically or as a hard rule, but since scaffold sets up the configuration for the entire screen, for the entire page, by adding an app bar and setting a body, this typically is a widget used in a screen widget. So let's add a new file which should hold this new widget, and I'll name this categories_screen.dart. The underscore screen part is absolutely not required. It's a personal preference so that we can quickly see that in this file we have a widget which we use as a screen. It's not a must use, but I personally like it a lot. Now, what should go into this categories screen then? Well, I'll create a stateless widget in here because right now the plan is to only output a list of categories. And I'll name this categories screen. So that's the name of my widget here. Again, to make it really clear that this widget is not getting used as part of another widget, but really to control the entire content of a screen. So the entire content on our device here on this in this app. Now, as always, when we create a widget, we have to import Flutter material Dart to get access to the stateless widget, the build context, the container, the widget class, and so on. And now the question, of course, is what do we return in this categories screen widget? Well, the idea here is to return a grid with all our categories. So a grid is basically like a list, but the difference is that in a grid we have multiple items sit next to each other, so side by side instead of just from top to bottom above each other. We can simply build a grid in Flutter with the grid view. So we have the list view for a simple list where we have no items side by side, and the grid view if we want to have items side by side. Now, just as to the list view, you can pass children. And by the way, just as the list view, the grid view also has a builder mode, which you can use if you want to build a dynamic amount of items. If you don't know in advance how many items you'll have, or if it's a very long grid, and therefore you want that performance optimization where only items that are on the screen are getting rendered. For our purposes here, however, we can definitely use the grid view with a fixed amount of children because we'll not have that many categories. They'll also not change dynamically, and hence we also should have no performance problems. Now I'll take care about the children here and the category items we're going to render in a second. Let's first focus on setting up the general look and structure of this grid, and we do that with another argument we have to pass, which also is mentioned here in this warning. We have to pass the grid delegate argument or parameter. So grid delegate is another named argument we have to provide, and the value for this looks really strange. It's a sliver grid delegate with max cross axis extend. That is a horribly long name. What does that do, however? Now, slivers in Flutter are really just scrollable areas on the screen. And of course, our grid, just like the list view, is scrollable as a default. Grid delegate, that simply means that for the grid, this takes care about structuring, layouting the grid. So this task of providing a layout is delegated away to this class here, so to say. Well, and with max cross axis extend simply means that this is a pre-configured class which allows us to define a maximum width for each grid item, and then it will automatically create as many columns as we can fit items with that provided with next to each other. So therefore here we pass a max cross axis extend, so the maximum extent or width of the tiles, so of the grid items, and here I'll use 200 pixels. And now it really depends on the device size how many columns we'll get in that grid. If we have a device with 300 pixels width, then we'll only have one item per row, and hence it will look like a list. If we have a device with 500 pixels width, well, then we'll have two items sit side by side. Besides this max cross axis extend, we can also define a child aspect ratio to define how the items should be sized regarding their height and width relation. And here I want to have a 3:2 relation. So of course you could just pass 1.5, but this expresses my extent way clearer. So for 200 width, I want to have 300 height in the end. And you can add some spacing, some cross-axis spacing of 20 and some main axis spacing of 20, which simply means how much distance is between our columns and rows in that grid. So with that, we are designing the look of our grid. Now we have to provide some children here, and that of course will be our categories. For that, I'll give you some dummy data, but first of all, I want to define how a category should look like. So now we'll add a definition of how the data we work with in this app will look like. And we did this earlier, if you remember, in an earlier course section for the transaction. There we provided a so-called model, and we'll do the exact same here. I'll add a new folder, models, and in there I'll add my category category.dart file. So there I will define how a category looks like in this application. In the category.dart file, I'll create a class named category, and this will now not be a widget, so I don't extend stateless or stateful widget. It'll just be a normal Dart class, which I can instantiate. Now, how should a category look like? Each category item should have an ID, which is a string, so a unique identifier. I want to have a title, so the name of the category, like Asian or Italian, and then also a color, which will be used as a background color. Now, just as we did it before in this course as well, I'll provide a constructor, category here, where we can pass data for all these different properties. And color is a type that's not baked into Dart. Instead, this is provided by Flutter, so we have to import material Dart from Flutter. Now in the constructor here, I'll use named arguments, but of course you could use positional arguments as well. And then here, I'll expect an ID, I'll expect a title, and I also expect to get a color. Though for the color, I'll provide a default of colors orange. Also to practice this again, this is how you would provide default values for named arguments in case no value is provided for this named argument. I want to make sure that we always get an ID and a title though, and we can do this by adding @required, which is a decorator provided by Flutter, and it is, for example, included in the material Dart file. So since we have that import, we get access to this decorator, and now we would get a warning or an error if we tried to create a category without an ID or title. So this is how a category should look like. And with that defined, I'll add a new file, dummy_data.dart, which you find attached, which you can simply add to your project. And this contains a const variable here, which holds a const and therefore unchangeable list with some default categories following our model. Now, one thing which I need to do here, I need to import material Dart from the Flutter package so that colors is available here. Should already be part of the attached file though, so you will not have to add this. And now also important, we're getting an error here because I'm actually creating a const list here, which means this can't change. The values in the list can't change. And this is only accepted if each category object is also immutable. So if we can't go to a created object and after its creation change its color to a different value. And therefore, we should go back to the model and add const in front of the constructor here. And now this means, since all these properties are final, the properties of an object can't be changed after the object has been created. And therefore, we now really have a list where the values will never change. So that's just some dummy data, which I provide right now, since we have no server or database where we could get that data from. And you find this finished file attached. This file has all the data I want to load into this categories screen now to render the categories. So let's now work on the category items. We need to output our category items here. We got the category data, but of course that's just, well, some data. We need widgets though. We need a list of widgets here in the grid view. And for that, we could certainly add the structure of each item here and manually map our list of transactions into that structure. But I rather create a separate file, the category item.dart file with a category item widget. This will be a stateless widget, and I'll name it category item because it will output a single category item in our grid of categories. And as always here, you need to import Flutter material Dart. Now, this category item here will be used in our categories screen here in this grid view. So how should a single item look like then? What should we return here in the build method? Well, first of all, which data do we expect here? Well, we probably want to output the title of the category and use its color. Remember that every category has a color to color the background of the grid item. So here we need at least two properties, a string, which is the title, and also a color, which is the background color. Of course, we then also should add our constructor to assign values to these properties here. And again, you can use named arguments here, or as I do it here, use positional ones for title and color. And now we want to output the title here on a nice card, where the card should have this background color. Now we could use the default card and try to adjust this, but I rather build my own one by using a container. That container here should have some padding, and for that I'll use edge insets all 15. And of course you can tweak this value and find a value that best suits your needs. Now important, edge insets all actually is a class and an object is created here. And as you learned in the Flutter and Widgets deep dive module, you can optimize the build process a bit by using const here in front of this. Because then when this build method reruns, this object here will not be recreated because Flutter detects that it's constant, that it can't have changed, and therefore that it should use the old one. So that's the padding on the container. Now besides the padding, we of course also want to have a child in there. And the child for a category can be really simple. It should be some text. And the text of course should be the title of the category, which I want to output. Now we'll certainly revisit this title to give it some styling, but for now let's use it like this. And let's work on the general styling of the container. And there we could simply assign color, which sets a background color, to color, which now refers to this color property. But I want to have a bit of a more complex background by using a decoration, which takes a box decoration object. And in that box decoration here, I want to use a gradient. We haven't worked with gradients thus far in this course, but often gradients can provide a nice look. So here's a good opportunity to add one. We add a gradient by instantiating the linear gradient class, which is provided by Flutter. By the way, there also are other gradients. If you just type gradient, you get an overview. You have a radial gradient, a sweep gradient. And as always, the official docs are a great resource to learn how to use these if you need a different gradient for your app. Here, and in a lot of apps, the linear gradient is perfect. And the linear gradient now, of course, needs to be configured. We need to set the colors between which you want to transition, and that's a list of colors. And then you also can define the direction over which it should transition. So let's start with the colors. There, I want to use my color, which I get here as an argument, but in a slightly more transparent version. And that can be achieved by calling with opacity on it. With opacity is a method provided by Flutter on its color class. And there we could set this to an opacity of 0.7 to make it slightly more transparent. And then I want to go from that slightly more transparent version of that color to the totally not transparent version of that color by just providing color like this as the end value of that gradient. Now for the direction, we can control this with a begin and an end argument. And the begin argument here takes an alignment geometry. Such an alignment geometry can be created with the alignment class, which gives you a couple of static properties with basically default coordinates for which this gradient then will start at. And there we could start in the top left corner and then go to the bottom right. So as you see, it's really simple to configure such a gradient with the help of alignment and this colors list here. So with that, we have the gradient. I'm not done with the box decoration though. In addition to the gradient, I want to set a border radius to have rounded corners. And I'll set this to border radius dot circular and then maybe 15. So now this will use a radius of 15 to round our corners. Border radius dot circular is a class constructor provided by Flutter to give you the setting for border radius, which needs a border radius geometry to, well, round off these corners. Now please note that here you can't use const because border radius, if you inspect that, does have a const constructor on all, but the circular constructor is actually not marked as const. So here we can't use const. So that's the general look of a category item. Now we can use the category item here in the categories screen. First of all, let's import our dummy data here. So let's import from the dummy data file, and that unlocks that dummy categories list which we have in there, all capital case, to mark it as, well, dummy data, which is application-wide global, which we can't change, which is just acting as a dummy data source. And in the categories screen, I now want to use that dummy data here. Because here we can now use a pattern which we used before. We need to provide a list of widgets. So let's take our list of data and map it into a list of widgets. So here we can refer to our dummy categories and call map on that because it is just a list. And call toList in the end because map gives us an iterable and not a list. And now we have a function that executes on every item in that dummy categories list. And that function therefore gets our category data. I'll name it cat data. You can give it any name you want. And it should return a widget which we want to render for every category in that dummy categories list. And that widget now, of course, is my category item widget, which we just created in the category item Dart file. So here we can now create a category item widget. And to that widget, we have to pass the title and, of course, the color. We get that from cat data, and there we extract the title and also the color, just like this. So with that, we got our category screen, and now it would be interesting to see whether that works. So how do we tell Flutter that we want to load this categories screen as the starting screen of our application? You do that in the main Dart file. There, in your root app, where you set up that material app or that Cupertino app, whatever it is, you have that home argument which you provide. And that points at the widget which should be loaded as the first screen in your application. So home here is a super important argument. Now, you will later learn that there are other arguments on the material app which also help you with loading screens, but home always marks the entry point of your application, the root screen of your app. And therefore here we now can point at our categories screen widget, and for that you need to make sure that you also import this categories screen widget here. So make sure you add an import path at the top of your main Dart file. Now, since I added this, we can now also get rid of my home page of this class and its state. We didn't need the state anyways, but now also the entire home page is not needed anymore because we load a different widget as our starting widget in our app. Now, one important note though before we see that in action. What's missing in the categories screen widget? If we have a look at it, there is something missing which I mentioned would be important in every widget you want to use as a screen. And that's the scaffold. Here, we're returning the grid view, but in the end, that would be the content of our screen. The screen itself also typically has an app bar and maybe some other things like some tabs. And therefore, here we should actually return a scaffold widget. And that scaffold widget should have our grid view as a body. So let's grab this entire grid view here, cut it, and add it as a body or as a value for body here on scaffold. Like this. Now we can also add an app bar here, and that can be a simple app bar where I for now only set the title to deli meal or whatever you want to name your app. Should be a text widget though. And since we're building it here, of course this can be a const text widget which never will have to update when the app rebuilds because the text in there is constant. This widget will never be different than it is initially. Now with all of that, restart your app and do it with that green icon here because hot reloading will not work. You need to do a full restart. And now you should see this here. And this doesn't look too bad. We have a scrollable grid of categories here. Now, a couple of things can be improved though. This text here doesn't look the way it does. The overall theme in general doesn't look the way I want it. Maybe we want to bring our own fonts. And some spacing around the grid would also be nice. So let's work on these visuals next before we then focus on making these categories tappable so that we can see the recipes for a single category. So time for some styling. Let's add some padding around the grid view. That's pretty easy because the grid view itself has a padding argument. And there you can pass good old edge insets. All maybe of 25 to add a padding of 25 in all directions around the grid view. And we can add const here to again make sure that this never is rebuilt. With this simple change, now we have some spacing around our categories, which doesn't look too bad. As a next step, I want to work on the general theme and also bring in my own font. For this in the project, I'll first of all add a new folder, Assets. And again, that's just one possible way of naming this. In there, I'll add a fonts folder. And attached, you'll find a zip file with some fonts where I'll use some of them in this module. So simply drag and drop these extracted fonts in there. As you see, again, I got two different fonts here, Railway and Robotic Condensed, in various versions, in a bold, very bold version, regular version, and so on. And as you learned, we now need to register these fonts in a pubspec.yaml file in order to use them. So in the pubspec.yaml file, you can scroll to the area where you have some dummy fonts code set up already, and now we can adjust this. For Railway, for example, which is one of the fonts, it can be found in the assets/fonts folder, and there we have a regular version of it, but we'll also have a bold and very bold, a so-called black version of it. So that's the normal version. But then we also have assets/fonts Railway bold here, and that will have a weight of 700. And now we can copy that and add it one more time, but now we can point at Railway black.ttf, which is another file we have in there. And Railway black gives us a font with a weight of 900, which is even bolder or thicker than this one. So that's one font. Let's copy it and add another one. Make sure you got the indentation correct here, by the way. In case you're not sure, you can always download my source code, which is attached to multiple lectures per module and always to the last lecture of each module to compare my pubspec.yaml file with yours, for example, because indentation really matters in this file and can mess up your application if it's wrong. And with that, let's add the second font, Roboto Condensed. And there we also go to the assets and fonts folder, but then it's named Roboto Condensed -regular TTF. And then we also have a bold version there. We also have a light version there. So let's add light here. For light, the weight is 300. And we have yet another version. So let's copy this one. And that's actually the italic version. And there we have no weight, but we have a special style, the italic style. So these are now all the fonts registered. Now we can start using them. And let's start using them in the main Dart file. In there, we set up our theme. And right now the theme is pretty simple. It's just the blue color. Of course, I'll leave it totally up to you which theme you want to use. I, however, will not use blue as a primary swatch, but pink. And as an accent color, I will go for amber, because I think that pink-amber combination really doesn't look that bad. I'll also change the canvas color to a custom grayish look with the from RGBO constructor here on color. And there I will use values 255, 254, 229, and 1. And of course, these are just some colors I came up with. You can definitely adjust this and tweak this to your personal likings. I want to set a default font family of Railway. That's one of the fonts we added. And I also want to set up a general text theme here. For that, I'll use theme data light, and then access the text theme there, and then use copy with here to again replace some parts of the default text theme with my own settings. Now you can always change whatever you wanna change, of course. I want to change my body here, both body 1 and body 2, to a text style where I override the color to a different color, basically a almost black, very dark gray with values of 20, 51, 51, and 1 used here in the RGBO constructor. And besides body 1, let's do the same here for body 2. And that's pure cosmetic, of course. You don't have to do that. And I also want to adjust the title here and give that a text style where I set the font size to, let's say, 24 pixels and the font family to Roboto Condensed, which is that other font we added. With that, back in the category item Dart file, where we have a single item in our grid, for the title here, I want to set the style to theme of context, getting access to that global theme. Text theme.title to use my general title style for this title. Now, since we added a font, quit your running development process or your running app with this red square and simply restart it without debugging. Also here with start without debugging, I just used the shortcut to bring it back onto the device, but now with a new app bundle that includes the font files. And with that, we should hopefully see our new colors and new fonts in effect there. So let's wait for that to finish. And I'd say this doesn't look too bad. Of course, feel free to tweak this to your requirements, but I'm quite happy with that. Though there is one thing which I do want to change, is maybe bring down that title text theme a bit to 20 pixels instead of 24, and instead add a font weight of font weight bold here to make it a bit bolder. Yeah, I think that looks quite decent. So with that, we have our categories here. We have our categories screen set up. Now, of course, we're all here because we want to be able to tap on a category and then go to a different screen where we can see the recipes for that category. So how do we make that work? Well, as a first step, it would probably make sense to have a new widget, a new screen to which we can navigate. Because the idea, of course, is to fully replace the content on this screen with the content of a brand new screen, the screen that shows us the recipes for that category. Hence, it's time for a new widget and therefore a new file. And you can name this however you want. I'll name it category meals.dart or category meals_screen to be consistent with my other file here, the category screen. So this will be the screen which shows us the meals for a chosen category. In there, let's add a stateless widget, which should have a name of category meals screen to basically fit our file name. And as always, import material Dart in there. Now, for the moment, to simply see something and work on that transition, let's just output a centered text here, which should display the recipes for the category. And we'll learn how to go there and how to pass data like the title of the selected category in a second. So now we got this new screen. How can we reach it from our categories screen? Well, actually, there's one more thing we should do here. We should, of course, use a scaffold and put this centered widget into the body of the scaffold, and also maybe add an app bar where we can show a title. And that title here will be the recipes, but of course, maybe we want to actually soon show the category name here instead of the recipes. So how can we now go to that category meals screen? In the end, we want to make sure that in the categories screen, we can tap a category item. So instead of the category item, we need to be able to tap these items. That, I guess, makes sense. To make them tappable, container doesn't have an on-tap argument or anything like that, but we can wrap container with a new widget. So let's use the refactoring tool to wrap it with a new widget. And there we could use a gesture detector, because a gesture detector allows us to add on tap, on double tap, and many other listeners, so that we can execute functions when a user taps or double taps or whatever our elements. But it would be nice to also have some visual feedback, so instead of a gesture detector, I'll use an inkwell. Inkwell is a widget which I briefly mentioned earlier in the course. It's basically a gesture detector which also fires off a ripple effect. So this material design effect you have when you tap something, where you have these waves coming out of the point where you tapped it. You can also add on tap here, but now you can also configure the ripple effect. For example, you can set the splash color, so the color of these waves, and for that I'll use my theme color, and there the primary color, simply by tapping into the theme with theme of context. And also set a border radius, maybe of border radius circular 15. Actually, not maybe, but it should match the border radius of your card, of your container, so that these waves nicely follow the shape of the container. So the border radius up here for the inkwell should match the border radius down there for the container. And you can simply set a different border radius to see the difference and why you might want to align them. Well, and with that, we just have to make sure that something happens on tap. And that something is, of course, that we want to go to a different page. How can we do this? Well, we can add a method here, which you can give any name you want. I'll name it select category. And in there, we can now use a tool Flutter gives us to change the page. So let's hook up on tap here to select category without parentheses. We don't want to call this when this gets parsed, but when the user taps here. And in select category, we now use a feature which I also mentioned earlier before, but which we only have briefly used, and that's the navigator. The navigator is a class, or a navigator here is a class built into Flutter, which helps you with, well, navigating between your screens. That's the core idea. Like theme or media query, it needs to be connected to the context, because you might remember that context is this object which has information about this widget and its position in the widget tree. And of course, something like that is super important for the navigator to know, because it needs to know what the current screen is so that it can add this page you want to go to as a screen on top of it. And what do I mean with as a screen on top of it, though? In mobile apps, and therefore also in Flutter apps, but not just there, when we navigate between pages, like a products and a product page, we typically do this by managing these pages as a stack of pages. And what's a stack? A stack basically is a list, you could say. The idea here simply is that when we go to the product page, we actually add this product page to the list, and when we go back from it, we remove it from the list. And you can imagine this list as being in a three-dimensional space where you always see the last or the topmost item of that stack. So the topmost page is visible. So if we add the product page on the stack and the products page was already there, the product page is now visible because it's the latest and therefore the topmost page. Therefore, we also speak of pushing and popping pages. We push a new page onto the stack so that it's the topmost page, and if we want to go back, we pop it off there. So in our code, this means that we now use the navigator here to push a new page. Now, before we do that, we need to make sure that we have context available here, so we should accept it here as an argument, and I'll name it CTX here to avoid confusion with this context. You wouldn't have to rename it. It's only there to, as I said, avoid confusion. And since I need the context here, we need to bind on tap to an anonymous function and now forward the context we get here by Flutter to select category when this anonymous function is triggered. So now back to the navigator. Now with the navigator set up and connected to the context, we can use push and pop on it. Now pop doesn't make sense here because we don't want to remove a page from the stack. Instead, we want to add a new one. Now you have various versions of pushing. You can push named pages. That's a feature I'll come back to later. You can also push and replace pages. That means that instead of adding a page on the stack or on top of the stack, you add it, but you remove the page below it. So you still only have one page in your list then instead of two. And that means that you won't be able to go back from that new page because you deleted the page you were coming from. We'll see use cases for this later too. Here, however, I'll push and keep the page we were on. And now what do we push here though? You don't push your widget you want to go to. So you don't add your category meals screen here. That's not what you add here. Instead, you add a material page route. And yes, there also is a Cupertino page route if you want to handle both. For now, I'll focus on the material page route, though the Cupertino route will work in the same way. The material page route is a class which you have to instantiate by adding parentheses, so by calling its constructor. And of course, it's available because we have that Flutter material Dart import at the top. Now, as you see, we can configure 4 things here. Important for us is the builder, which defines which widget should be built with the help of material page route. We need material page route as a wrapper, so to say, to handle things like the animation from the old page to the new page and so on. Full screen dialog is a boolean which you can set to control whether you want to have that default animation where the new page kind of slides in, or if it should basically be a full screen overlay rather. And settings will become important later, we can ignore it for now. Same is true for maintain state, we don't need that at the moment. So let's add a builder, and the builder here gets a context passed in automatically because again the function you provide for a builder here is now executed by Flutter. And here I'll name the context just C, or actually use an underscore since I won't need it. And now in here we have to return the widget which should be used as a new page now. And here the idea of course is to return our category meals screen. So for that we now need to import it with a relative import path here from our category underscore meals underscore screen.dart file. And of course we instantiate it here. So with this we are creating our new screen as part of this material page route, and with the help of push on the navigator we should be able to go there. So with that, let's do a full refresh here with the green arrow and go back to our application. Back here in our application, click a category. And what you see is that you now get this transition to this recipes page. Of course, to the same page for all categories, but still. And you automatically get a back button up there. And of course, on Android devices, you can also use this back button. So that's now, of course, really nice because now we can switch to a brand new page and we automatically got this back functionality managed by Flutter so that we can also go back to the categories page here. Now, of course, it would be nice if we had some information in that category meals screen, which is coming up, about which category was loaded, so that in here we can actually display the right recipes for that category. So we would want to get that information about which category the user visited in that or on that page. For that in here, we can add a property, category ID maybe, which should be a string, and another final property, category title. And of course you can give these any names you want. Then let's add a constructor by repeating the class name as you learned it. And there let's assign values to this category ID and the category title. So now when we create the category meal screen, we need to forward that information to that created screen. So in category item, thankfully, we can get that information. We have the title already, and the ID is also something we can expect there by simply adding it as another argument here we want to have in the constructor and another property we manage here. And now in the place where we create our category items, so in the categories screen, we simply have to forward that ID, and thankfully that is available here in our cat data. So it's no problem to forward that. So now we have that in category item, and there we create that category meals screen, which now wants that ID and title. Well, since we have it here in the category item widget, it's no problem to forward it. We can simply forward ID and title like this, because since the select category method runs inside of a single category item, we only have one clearly defined ID and title inside of this widget. So now in the category meals screen, we can use that, and for example, instead of showing the recipes here, we could output the category title here, which seems more appropriate. So if we save that and we go back, and I click on Italian, now we see Italian here in the app bar instead of just the recipes. And if I go to a different category, we see that different category's name here. So that is how we can pass data into a new page if we load it like this, by using navigator push. Now, since I'm saying it like this, it already sounds like there also is a different way of loading pages, right? Let's have a look at that way too. Besides using navigator push like this and creating our material page route here, we can also set up so-called named routes. Now, what's the idea behind named routes though? The bigger your app gets, the more difficult it can get to manage all these manual route transitions where you then create your own widgets and so on. This can be very cumbersome, and it can be hard to see where in your app people can navigate to which page. And most importantly, it can be difficult to see which routes and which screens your page generally supports. And for that, in the main Dart file, you also have more options than just setting home and then taking it from there. Instead, you can set up a so-called routes table with the help of the routes argument. The routes table takes a map, and therefore you need curly braces to create that map, where you have string keys which identify a route, and a route is really just a screen. And then the value after the colon is in the end your creation function for that screen. So in there, you could, for example, say that you want to have an identifier of /categories, and you could have any text here. It's just a convention which also is taken from web development, that you have paths with a slash at the beginning, because in web development you would have yourpage.com/categories as a URL, and we kind of took this and borrowed this for mobile apps. But in the end, this path here is totally up to you. You could also name this ABC. But I'll go with /categories. And now on the right side, you have your builder method, where you get some context created automatically by Flutter as an argument, the context of this builder function. And on the right side, for example, you create your category meals screen. And therefore, maybe here as I identifier category meals, category-meals is a better identifier. So then we create the category meals screen here. And that means that we also should import it here, of course. So make sure you add your relative import at the top of the main Dart file. And with that, you can quickly see that you seem to have that route available in your app, besides that default categories route. The problem, of course, is that category meals screen wants some data. There, we want to get the ID and the title of the category we're loading. And this isn't really available anymore now, because we expected to get this through the constructor. The constructor now, however, is called in the main Dart file, and here where it's called, we have no idea about which ID or title the element we selected has. Thankfully, though, Flutter also has a different mechanism of passing data between routes. Besides using the constructor of the screen we're loading, it also has its own messaging system, you could say, its own system for passing data. So in the category meals screen here, we can actually comment out this part. You could also remove it. I'll just leave it here for reference. And instead, when we load this page, so here in the category item, we now do two things. We now will not push, but push named instead. And push named does not take a material page route, but it takes the path, so this string identifier to which you want to push. And that would be /category meals, and hence we should use that here instead of push named. But push named also takes arguments. We can provide some arguments here which we want to pass along. Arguments here can be anything. It could be some text, it could be a number, it could be a map, it could be an object. In our case here, we could pass a map with maybe ID, and that will hold as a value our ID here. And then also our title, like this. So now we pass this map as arguments to the new route, to the new screen which is loaded for this route identifier, which is leading to the category meals screen. The question is, how can we now extract the data in the category meals screen? Well, in there, in the build method, you can extract your route arguments and store them in a variable, maybe route args, by using modal route, another class provided by Flutter material, which you also connect to your context with auth context. And then there you can get information about the route that was loaded to display this widget, so to say. You have a settings object there, and there you have an arguments object, or your arguments key. And that gives you the arguments as you pass them here when you pushed that named route. So in this case, we pushed arguments which are a map of strings. So here we can also inform Flutter and Dart that whatever we get here as arguments will be of type map, where we have string keys and string values. So this is how we extract the route arguments. Now we can also get our category title here by accessing route args, and then, as you always do it on maps, by using the key here in square brackets. Whoops, that, however, should be the title, of course, since I named that category title. And here I have the category ID, which I get with route args ID, like this. So this is also how we can pass data around. And therefore now, if we do a full refresh with the green arrow, we should again be able to navigate, and we are, and we see the right title. Now, of course, you might be wondering why you would use this more complex approach of passing data around and why you would use these named routes. And the answer simply is that for bigger apps, this can be easier to manage because you have your clear list of available routes here in the main Dart file, and it's easy to see which different areas your app has, which different screens can be loaded, and how you may get there. So it's really just one option you can use to have a cleaner app, which is easier to understand and to get into. I got two other annotations for the routes here, the named routes. For one, home always also has an automatically named route, which is just slash. So if I would add a route just slash, like this here, and I then remove this home key, it would still work. Of course, I have to provide a builder function here, though. So if we do this, if I add this slash route here with a builder function that loads my category screen, this still works, and I still get my categories here, and I can navigate around and so on. If you, for some reason, want to make sure that the default behavior of Flutter is to not load slash but a different route, you can also add an initial route argument to your material app, and the default value is just slash, so you don't need to set this. Now, one last important note about these route names. Of course, you can type them like this in the main Dart file, but the downside of that, of course, is that when you want to go to your category meals here, for example, you manually have to type that name when you use push named. Now, of course, it's easy to have a typo here and suddenly your app is broken, and finding that error can be hard. Hence, a common practice is to add a static constant property to your screens. So here for the category meals screen widget, you would add a static const property, which is a property that can be accessed without instantiating that class, which has a name of a route name or a screen name or anything like that. The name is up to you. And there you would store your route name, like category meals. And the advantage of this approach is that you can now go to the main Dart file, and instead of hard coding it here, you would point at your class, category meals screen, not instantiated, so don't add parentheses, but simply refer to that static property like this, which gives us a string and which is therefore a perfectly fine key here in our map, because route name gives us a string. And now in the place where you push, you would do the same. So here you would simply use category meals screen and access route name. Of course, make sure for that you're importing category meals screen Dart in the file where you use that. So that's simply an approach which is less error prone and therefore preferable. Ultimately, it's of course up to you if you want to use named routes or if you want to push routes as I showed it in the first approach, but especially in bigger apps, I would definitely recommend checking out named routes. So with the basics of routing covered, let's now make sure that we continue working on the app before we then dive into other navigation and routing features like tabs. And working on the app, of course, means that when we, for example, select Italian as a category, it would be nice if we could, well, display some recipes here. So that's the next thing I want to work on. In the category meals screen here, instead of showing that center text, the goal, of course, has to be to show something else, to show a list of recipes. So for that, instead of having this centered widget here, we can add a list view, which we use to output the recipes. Now, just as you learned it before in the course, you can build that list view in two ways. You can either use the constructor here and add children, or use the special builder constructor to have a list view where items are managed such that items that are not on the screen are actually removed and only items that are on the screen are rendered, which provides a better performance for very long lists. Now, since we potentially have a lot of recipes, a lot of meals, which we want to show in that category, and we don't know in advance how many it will be, I will go for the builder approach here. Now, when using the builder, you need your item builder argument, where you provide a builder method. So the method this list view builder will call for every item, for every list item it tries to add to the screen. And there you get a context and you get the index of the element which is getting rendered. And then here in the body of that item builder function, you have to return a widget, which is built as a single row here, or as a single list item. Now, besides that, you also need to tell the list view builder how many items you will have, and that can be done with item count here. Now, what's definitely missing here is, of course, a list of recipes. In the dummy-data.dart file, which I simply use as a dummy data source here, thus far I only have categories. Now it's time to also add recipes. For that, let's first of all define how a recipe or a meal should look like. So I'll add a meal.dart file, which describes the model for a meal. So in there I'll add a class, meal, and now of course there are thousands of different ways of defining how a meal should look like. Here's my definition of it for this application. Every meal should have a unique ID by which we can identify it. In addition, every meal should have a list of category IDs to which it belongs, because every category here in the dummy data has an ID to identify it. And of course, every meal should be part of one or more categories. So here I want to have a list of strings which are my category IDs or categories simply. So that's another thing which we need in a meal so that we can map meals to categories. Besides that, of course, every meal should have a title or a name, whatever you want to name it. And it should also have an image. And here I'll use an image URL so that we use a network image. So we'll not store the image locally as part of our app bundle, because in a real app, these meals would probably be created on some server and fetched dynamically by your app. You don't want to hard code all the data into your app bundle. And therefore, we will use a network image here so that the image doesn't have to be shipped with our app. Hence, we could also, if we would be fetching our recipes from a server, which we are not here, but if we would, then we could also, of course, fetch new recipes with new images, which didn't exist when we created the app. Hence, this external image with the image URL. Now, obviously, every meal also needs a list of strings that describe the ingredients. And of course, you could also have a more complex data model here. You could say every ingredient is not just a string, not just the name of the ingredient, but it could also be a mixture of name and quantity. But I don't want to make this too complicated here, since the main focus of this app, of course, is navigation, and therefore we'll just go with a list of strings, so just a list of ingredient names or names where the quantity is already involved, like 3 tablespoons of sugar, something like this. Then we also need steps. That's another list of strings, simply text steps that describe what you have to do to create that meal. We also might want a duration that gives viewers of our app an indication of how long this meal will take to create or to prepare. And maybe we also want to say something about the complexity of that meal, and maybe also about the affordability, just some extra information we have as part of this application. For this, we could add a complexity variable, and now the question is, which type of data would that be? It could be a string, so that we have, for example, a value like simple, but then we have to remember these exact names when we work with them in our app, when we compare them or anything like that. Instead, we could use numbers, which makes this a bit simpler and avoids typos when we use that name in the app. So we could say 0 is simple, 1 is medium, and 2 is difficult. The problem with that is that we have to remember this mapping of numbers to meaning. So that 0 means simple is something we as a developer have to remember. And therefore, an int is a good but not the perfect type here. A better type is a enum. And we used enums before, we just haven't created one ourselves. You do create a new enum by simply typing enum, which is a keyword in Dart, and then curly braces. And now between the curly braces, you add your different values or options this should provide. Because an enum is essentially a type that helps you create a choice amongst a couple of alternatives. So here, if we have an enum, which we give a name of complexity, and that's also important, you need to give your enum a name, then you add the values here. For example, simple, challenging, hard. Now behind the scenes, what Dart does is it simply uses 0, 1, and 2 here. It maps these values here to normal integers. But you as a developer can work with the labels, which is of course simpler for us humans, and for the computer, again, numbers are used. And then we can use our complexity enum as a type here, because an enum, just like a class, also creates a type which you can use. And now we can use this enum type here to describe the complexity of our meal. And we always have a choice amongst these three options. We have to pick one of these three options, otherwise Dart will give us an error. And we can't mistype because the way we use an enum is like this. If we assign a value here, we do it by accessing our enum, and then with the dot notation, we get auto completion here, and we use one of these available values. And if we would add some other value like difficult, well, then we would get an error here in Dart. So that's the amazing thing about enums, and that's also why, of course, Flutter uses enums heavily, and we used enums implicitly thus far already for some configuration values like alignment and so on, which sometimes provided us enums. So here we have the complexity enum. I will create another enum here, and that will be the affordability to describe how affordable that meal is. The affordability could have values of affordable, pricey, and luxurious. And of course, it's up to you how you build this and which values you want to use. And with that affordability enum added, we can of course add another variable or another property here to our meal class. We can use affordability as a type here for an affordability variable or property on the meal class. Now we're almost done, but there are 4 more properties which I want to have here. And these are properties which we'll later use for filtering. These will be Boolean values, and I want to use is gluten free here. Another bool for is lactose free. Another bool property is vegan. And another bool property is vegetarian. And again, this is something we'll use later once we added this settings or this filterings screen where we can make sure that certain recipes, certain meals are not included in our app. And for that, and to exclude meals, we of course need to describe on every meal if it matches one of our filters. So that could be a dummy data model. Now, as always, I want to provide a constructor here so that we can create meal objects and populate all these properties. And for that in the constructor, we essentially, well, set all these properties. Since we have a lot of properties, I'm not the biggest fan of using positional arguments here, because you then have to remember that the first argument is ID, the second argument is title, and so on. So instead, I'll use named arguments here, and then assign values to this ID, this categories, and so on. Now, before I continue, it's important that I want to make sure that all these arguments are actually required. So that means that you must not leave an argument out here. And therefore, we should import a package out there, and that's the Flutter package, and there the foundation Dart file, because this foundation Dart file unlocks one special decorator, which we can use here in front of our arguments, the @required decorator, which ensures that we get an error if we try to create a meal without one of the required arguments. And now we can simply require all these properties we have here as arguments. So the title, the image URL, the ingredients, of course, also the steps, Also, of course, the duration. Then, of course, also the complexity. Then the affordability. And so on. So I'm going through all my properties. Is gluten-free. Then also is lactose-free. Then, of course, also required is vegan, and required is vegetarian. And with that, let's see, which error am I getting here? Is gluten-free? Yeah, I missed the this keyword here, so let's add that here. And with that, this is looking good. This is the finished meal class here, which indeed now allows us to add meals. Now with that, we can add some dummy data to the dummy data Dart file, and you find an updated version of that file attached to this video, which now does not only include the categories, which we already had in there, but which also contains a list of meals. So you can simply copy and paste that into your dummy data Dart file. Here it is. And there we then have a long list of meals which you can add. Now, for meal to be available, you need to make sure that you also add an import to this file, if it's not there already, to the meal Dart file in the models folder. And one thing I forgot is in the meal Dart file, of course, our constructor here should be a const constructor so that we can create immutable values here and also add const in front of this list here, the dummy meals list. So with that, we added our dummy meals. We added the meal model here. Now let's go back to our meals page there and make sure that we output our meals. Now, of course, for outputting the meals, I only want to output the meals that match this category ID. So if we have a look at the dummy data, we see that every meal has a list of categories. And here I'm referring to the IDs which are, well, set up as IDs on the categories. So we'll have to check all meals and find the meals which include the category of the category we selected in their categories list. So for that, we first of all need to import our meals in here. So for that, let's add an import here in this file, and let's import our dummy data Dart file in the category meals screen. And now with the meals imported, we need to find the right meals here based on the category ID we selected. So we can add a new final property, which we could name displayed or filtered or category meals. I think that name makes sense. And then you can refer to our dummy meals. And dummy meals is available here because we're importing the dummy data Dart file where we expose this as a constant. And the dummy meals can now be filtered with the where method. Where returns as a new iterable, and we can convert it to a list with the toList method, which only contains elements that satisfy a condition which we specify in an anonymous function we pass to where. This function receives every item. It goes through all elements in dummy meals. It receives each item then here as an input. And we have to return true if we want to keep it in the new list, which is generated, or false if we don't want to include it in the new list. So here we want to return true if the meal we're looking at has the category ID included in its categories. And thankfully, categories is a list, and on list we not only have where, but Dart also offers us a contains method. And contains returns true if that list contains a specific value. The specific value we want to check for is the category ID, of course. If that category ID is included in the categories of our meals, then this meal belongs to that category. So category meals now would be our filtered categories, and hence here for the item count we can now use category meals.length because that is the amount of items we have. And now we can start building our list item. And for a very simple start, just to see whether that works, I'll just return a text here that should output the name of the of the meal, so that we can simply see whether we're identifying different meals before we then start on styling and layouting the meals in an appropriate way. So here we can access category meals, and then for the index for which this list item is getting generated. And then, since this of course is of type meal, we have the title available here. And with that, we should be able to save this and do a full restart maybe, and now hopefully have an application where we can indeed display the meals for this category we selected on the right screen. So now if I click on Italian, I see spaghetti with tomato sauce. That doesn't look too bad, looks pretty Italian to me. And if I go to the dummy data Dart file here, I indeed see spaghetti with tomato sauce is part of C1, which is the ID of Italian. Now let's see if something else is part of C1. Nope. We have a couple of values that would be part of C10 though, which is summer. So let's see whether we also can display multiple recipes. If we scroll down to summer and click on that, yeah, here we got 3 items. So this seems to work. Filtering and selecting based on the ID seems to work. Got no hamburgers though, that's strange. Let's quickly check that. Pretty sure we should have a hamburger. Classic hamburger has C2 as a category. Oh, that's quick and easy. That should be C3. So for the classic hamburger, let's maybe add it to both C2 and C3. Yeah, and now it's there. So this seems to work. Now we can select different categories and display different meals based on the category we selected. The next step is to work on how this is presented, because of course this is not really the way we would want to look at a meal. For presenting a single meal, I of course don't just want to output the text. Instead, I think it makes sense to create a new widget for a single list item here, because it'll be a more complex structure, a more complex widget composition of a couple of built-in widgets, and therefore I don't want to clutter this sub-widget tree here in the category meals screen, but instead create a new item or a new widget, just as we did it for a category item, where we also have a separate widget for displaying the categories in our grid of categories. So let's add a meal item here maybe. And now there is one thing which I want to improve about our folder structure before we continue. We have a couple of widgets which we use as screens. We have these 2 widgets to be precise. Then we have widgets which we use as part of other widgets. And that's of course a core difference, a totally different way of using widgets. Both are normal widgets. A screen widget also is just a class that extends stateless or stateful widget. But the way we use these widgets, of course, is totally different. So here it would make sense to create more subfolders to make it clearer which widgets and which files contain which kind of widget. So here we could add a widgets subfolder for these normal widgets, which we include into other widgets, and then a screens subfolder for the screen-like widgets. And then we can move categories screen and category meals screen into the screens folder, and category item and meal item Dart into the widgets folder. And the dummy data Dart and the main Dart file will stay where they are. I think we can definitely keep those on the root level, though you could also create some data folder for the dummy data if you wanted to. Now we will need to fix a couple of imports, like here in main Dart. Category meals screen is now found in the screen folder, so we need to update our import to screens folder to point at that folder. And the same is of course true for the categories screen Dart file. In the category item Dart file, there we also point at the category meals screen Dart file. So there we first of all need to go up 1 level with 2 dots, and then into the screens folder, and then into the category meals screen Dart file. And in our screens Dart files here, the dummy data is found 1 level above, so we need 2 dots here. And the category item is also found 1 level above, but then in the widgets folder. And in the category meals screen file, dummy data is found 1 level above. With all that fixed, now we can work on the meal item. And a meal item is simply another stateless widget here in the end. I'll name it meal item, And as always, you need to import Material Dart from the Flutter package. Now, how should a meal item look like? And remember, this is simply the widget we use as part of our list of meals we're outputting once we selected a category. So how should such a list item look like? Obviously, you can style and build this in whichever way you want. Here's just one suggestion, which also will use a couple of new features, new widgets, new ways of configuring widgets, which we haven't used before in the course. Because that's, of course, also the core goal, or one core goal of this course. I want to give you many examples of how you can build Flutter apps and how you can work with the Flutter widgets. I'll start by adding an inkwell. And we did the same for the category item to have a clickable item where we also have this ripple effect. I want to have that effect here too, so inkwell makes a lot of sense. On tap, I want to make sure that we trigger some method which then actually shows us the detail page for the selected recipe. So here I'll add a new method which doesn't return anything, which I'll name select meal. And for now, I don't do anything in here. We'll add the logic later. I'll just connect it to OnTap for the moment. Now, the inkwell will not just have a tap effect, but should also have, of course, a child, which is the actual widget that's wrapped by the inkwell. And there I'll use a card, so this built-in card widget Flutter offers. Now, in that card, or on that card, I want to override the default shape by setting the shape argument. And with the shape argument, we can change the way this card looks. Instead of having a rectangle, we can get a rectangle with rounded corners, where we can define how strong the rounding effect should be, and so on. And indeed, that's what I want here. So for the shape, I'll set a rounded rectangle border object, because shape, if you check it, needs a shape border type, and shape border actually is created by rounded rectangle border. This gives you a shape border type as well. And rounded rectangle border takes one important argument, the border radius you want to have for your corners. So this is a typical pattern of how you can assign rounded corners to certain widgets, like the card widget in this case. And border radius in turn needs a border radius object, but there, for border radius, I'll use the circular constructor and then set a radius of 15. And this will now give us rounded corners on this card with a radius of 15. So that's the shape of the card. Besides the shape, I'll set the elevation to 4 to have a little bit more shadow behind the card. And a margin with edge insets all of 10, so that we have more margin around every element, around every meal here. With that, we can add a child, so the content inside of the card. And there I want to have a column, because I want to have multiple widgets above each other, on top of each other, so to say. Now, as you learned, column takes a children argument, and there we provide a list of widgets that should be part of that column. The first widget I'll add is the stack widget, another built-in widget which allows us to add items on top of each other in a three-dimensional space. So you can have an image with a title on top of the image, so as part of the image, so to say. And that's exactly the effect I want here, by the way. I want to display the image of the recipe, and on top of that image, I also want to show the title. Stack takes a couple of children, which are the child widgets that are placed on top of each other, and the first child widget will be my image. Now, I'll not create the image directly like this. Instead, I also want to have rounded corners on the image. Otherwise, it will not look good in that rounded corners card. Because if you would put an image with normal corners, without rounded corners, into that card with rounded corners, the image corners would basically overlap the card and you would not see the rounded corners effect on the card. And therefore, you need to clip the image, which means you have to move it into a certain form. You want to add rounded corners there as well. Now, you can't set rounded corners directly on an image. That's simply not supported. But you can use another widget to wrap it around your image widget to basically cut off or clip the corners of the image so that you have that feeling of having rounded corners, because the image is simply forced into that form. You do this with clip rect. Now, this is a widget which is also part of Flutter. You don't use it that often, and the name certainly looks a bit strange. But this is a widget which you can use to basically use any other widget as a child and force it into a certain form. For example, into a widget where the top corners are rounded. So clip rect indeed does take a border radius, just like rounded rectangle border did for the card. Here we could use rounded rectangle border instead of clip rect, because card supports this shape argument and then handles the rounding internally. Here clip rect needs to be used as a helper widget because image does not support this internally. Now the value for border radius here, however, is also border radius, but then not circular, but only allows me to set the radius for each corner separately. And I only want to round the corners on the top left and top right, because these will be the corners that would overlap across our card corners. Why not the bottom corners as well? Because for our image, remember it's part of a column. We'll have another element below the image. To be precise, I want to output information about the affordability and so on below the image. So the bottom corners of the image will not match the bottom corners of the card. The top borders will, and therefore we have to round the top borders. So here we can select the top left corner and set that to radius circular 15. So of course the same value I used up here. And then do the same for top right. Radius circular 15. So with that, we have that clipping set up. Now we have to define the child which should be clipped. And that's the image. And there we can use the .network constructor to create an image widget which reaches out to the network to fetch the image. Before the course, we used image.asset to use a local image that's included in our app. Now that's simply not the case here. Every meal in our app has a URL that points at the image, and therefore we'll have to use that. Now, of course, the URL of the recipe of the meal is something we need as an input to our widget here. So let's add a couple of properties in general, I'd say. All the properties we need to properly display a meal in our list of meals. That will be the title. That will also be the image URL, of course. But it will also be, for example, the duration, which is an integer. And you can check the meal here, the meal model, to learn which property of our meals has which data type. Now, what I also want to display here in the list already is information about the complexity. So the type here is complexity, and for that, to use it in this file, you need to import it from the models folder, and there the meal Dart file. Now we can accept or use complexity as a type here in the meal item Dart file. I also want to use affordability. That's exported by the same file. And with that, I'd say we have a solid setup. Now let's add the constructor for meal item. And there you can use named or positional arguments. I'll use named arguments here, and I want to get the title, the image URL, the affordability, the complexity, of course, and the duration. Now, just as before, we can also add @required in front of every argument here. This is available because we are already importing Flutter Material Dart, which unlocks the required decorator to make sure that meal items can't be created without these arguments. So now that we're getting this back down to the image network, we can of course simply use the image URL, which we're now getting as an argument when this widget is created. Now the image should also be configured. I want to set a height, for example, a fixed height of 250, so that the image never is bigger than that, and we have the same image height on every recipe. And for the width, however, I want to set double infinity, so it should take all the width it can get. To fit the image nicely into that box which we create here, I'll also add the fit argument, because of course by default you might have an image that has an aspect ratio which would look distorted if you squeeze it into the dimensions you have here. And to automatically resize it or crop it such that it nicely fits into this box, the fix argument helps us, and we can set this to boxFit.cover, and this will both resize and crop the image so that it fits nicely into this container. And now before we continue, let's have a look at this. Let's save this and let's now go to category meals screen and there replace the text here with our meal item widget which we worked on. For that you need to add an import, of course, at the top. So import pointing at the widgets folder and there at the meal item Dart file. And with that we can create our meal item down here, and of course we now have to pass data to it, data about the selected meal. So the selected meal is of course category meals index, and now here we expect a title, for example, so we should access category meals index title and pass this title. Besides the title, we also want the image URL, so let's pass category meals for the selected index dot image URL. For the duration, we have to pass category meals for the selected index duration. For the affordability, unsurprisingly, we use category meals for the selected index affordability. And for the complexity, we use category meals for the selected index here in our item builder, and then complexity. With that, we're creating a meal item here, which we're outputting. Right now, we're not using title, duration, affordability, and complexity, but we should be seeing images at least. So let's save this and have a look. If you go back to the application, you should now see some images there through which you can scroll in all the categories. In some categories, we only have 1 or 2 elements, but in other categories, we have more elements. And there, once they're loaded, you should see these images. And that's, of course, pretty nice already. Looks quite delicious already, in my opinion. The next step, of course, is to make sure that we also show the title, that we make these tappable, and that we maybe also show some extra information regarding complexity and so on. Please also note on every image that we have rounded corners at the top, but not at the bottom, and therefore at the bottom we have normal corners, even though theoretically our card has rounded corners on all edges. You see this if you load a category for the first time and the image hasn't been loaded yet. Then when you see that white box, you see rounded corners at the bottom too, but thereafter, once the image is there, the normal borders of the image overlap these rounded corners. And that is what we fixed with clipped are erect. Now we're not fixing it on the bottom because as a next step, we'll add more content below the image as well. And therefore the image will not take the entire height of the card or not be the only content of the card. So let's continue working on this now. Let's continue working on our meal item. We have the image, we're clipping its top borders, and keep in mind that the image is part of a stack. That means we can now also add another widget which sits on top of the image. And that's the plan indeed. So on top of the image, and therefore after clip are rect, but still in the widget array here, or the widget list for stack, I want to add another widget which is placed on top of the image. And that should be a text widget. The text should of course display the title of this image here. And I also want to set some style here, not through a theme because I really will only use that style here. I want to have a font size of, let's say, 26. And then also set a color, which should be white. Besides that, I want to set soft wrap to true, so that the text, if it should be too long for the card container, is actually wrapped. And I'll set overflow to text overflow fade. So in case that it doesn't fit into its box, even with wrapping, now it would just fade out and not overflow and basically look ugly, but instead it would be cropped, would be clipped in its box that is reserved for it, and just fade out if it needs to exceed that box. Shouldn't really happen, it's just a safety mechanism. With that, we save this and we load Italian food. Here's our text. Now that's okay, but I would want that text placed differently, not on the top left. When you're in a stack, and that's new, we haven't done this before, but when you're in a stack, you can use a special widget which really only works inside of a stack. You can wrap text with that widget by using the refactoring tool and wrap with new widget, and the name of that widget is positioned. Positioned allows us to position the child widget in an absolute coordinate space. And for that we can add a couple of properties. bottom, left, right, and top. So we can tell how far away we want to be from the bottom, from the left, from the right, and from the top in our stack. And the stack container itself is defined by its biggest child, which here clearly is our image. So effectively in the box of that widget here, of that image, we can now position that text. And there we could say that we want to have 20 pixels distance from the bottom and 0 pixels or 10 pixels distance from the right to position it in the bottom right corner. And now if you save this, this text moved down there, which in my opinion looks better. So this is of course just my opinion. You can play around with that and position this differently if you want to. But now we have that text down there. One thing we see, for example, here is that here this text still goes outside of the available box. And to prevent this, we need to make sure that this text, which is configured to fade instead of to overflow, actually has a container that constrains it. So let's wrap the text here into a container widget, and we can now give that container a width. And I want to use a width of 250, maybe even 220 to be a bit smaller than the image. Also, to ensure that the text is always readable, even on bright background, I'll add a background color here for the container with the color argument of colors black 54. That's basically black, but with a certain amount of transparency. To be precise, with 46% of transparency or 54% of opacity. And with that, if we now save this, now this looks way better. Now we have that black background. Maybe we now also want to have some padding in that container so that the text doesn't sit directly on the edges of the container. So we can add a padding of edge insets, symmetric maybe to have different padding to top and bottom and left and right. So vertical padding could be 5 and horizontal padding could be 20 maybe. With that saved, this doesn't look too bad. Looks quite nice to me. I'll actually now ramp up the width of that container again, because I of course had one mistake. The width of the image is not 250, that's the height. So we can certainly use more width here in the container. And it will fit nicely here into our image. So now these are the images with the title on top of it. I like that style, looks quite decent. Of course you can style this even more, add rounded corners to that text container if you want to, but I'm happy with that style. My next step is that I of course also want to add some information below that image title thing here. So below the image and title, so after this stack widget here, which ends here, but still inside of the column widget, child array, child list here, there I now want to add a row, because now I want to have a couple of pieces of information set next to each other below that image. Maybe add a padding widget around the row before we continue with the row itself to have some distance to the image. So a padding of, let's say, edge insets all 20, so 20 in all directions, and then our actual row child. Now inside of the row we of course have children, just as we have it in a column. And now, and that as always is totally up to you, I want to have 3 items next to each other here. Each item itself will be a row, because each item itself will consist of 2 widgets. And the 2 widgets that make up a single item here in our outer row is an icon and then also a text. So what's the icon? First, I want to display the duration, so the icon should fit that, and for this we can actually use icons.schedule, which displays a little clock. So that will be the icon. Now I'll also add a sized box between the icon and the text to have some spacing with a width of, let's say, 6. And then the text here will be the duration. The duration for every meal is just a number, and in this app here, that will simply be the duration in minutes. So here I want to output with string interpolation, so with this $sign, duration. And if you only have one variable you're referring to or one property, you don't even need the curly braces. And then also to give the user some idea of what this number means, I'll add min for minutes after this. If we save that, then we see this below our images and titles. That's exactly what I want. Now, besides the duration, we'll have two other pieces of information. So in that outer row here, I'll then basically copy this row, which makes up a single information item here in that row. And yes, you could therefore also extract this into a widget if you wanted to. So here, let's repeat that. And the second piece of information I want to output here is the complexity. For that, I think the work icon is a good fit. Of course, you can explore other icons if you have another icon you prefer. And now the question is, what is the text here? Because remember that complexity actually is an enum. And these labels here are not strings. This is not text we can output in our app. These are just human readable labels for us as a developer. The actual value stored behind that is a number. Now, I certainly don't want to output a number here though. I want to output a text that makes sense to humans. So now we need to translate our enum labels here into text which we can output. And for this, I'll add a getter in my meal item class here, which will return a string because I want to have the text which I output. Then we need the get keyword to create a getter, and I'll name it complexity text because that is in the end what this getter derives, what it gives us. In here, we can now have a couple of if statements to check if complexity is simple, and then we output text A. If it is challenging, then we would output another text, and so on. So we could have if statements like complexity, is it equal to complexity.simple? This is how we use an enum in a condition. We access the value with the dot notation, and keep in mind complexity here is of that type, so this stores such an enum value, such a number. So here we compare if that stored complexity is equal to this complexity, and if this is the case, we could return simple as a text here. Now I say could because that is a perfectly fine approach of doing it, but if you have multiple such if statements, which you would have here, you would have one for challenging and one for hard, and then have different texts here. If that is what you have, then Dart also gives you a different language feature, which we haven't used before, the switch statement. Switch statements also exist in other programming languages. They're not exclusive to Dart, and they allow you to combine multiple alternative if statements into one single statement. For a switch, you first of all define the value you want to analyze. So in our case, that's the complexity variable. That's the part which we compared to other values in our if statement. Then you have curly braces, and now you define multiple cases with the case keyword. Now, these cases are simply the different values complexity could have. So one case is complexity.simple. If complexity is of type complexity simple, then with a colon, we execute the code here below that case, and that colon is important. So then we could return simple here, and even though this code will not run, it's also typical that you add a break statement here. You need it if you don't return here. This avoids that other cases are hit as well, but if you return it, it's technically not required. Since you typically add it in switch case statements, though, I'll add it here too. And now you can add your other cases, like complexity challenging. There I want to return challenging and also break thereafter, and then also have a case of hard here, where in that case, after the semicolon, after the colon, I return hard. And also break here. And then you also typically provide a default case, which is triggered if complexity has a value you're not covering in one of your cases. And the default case here simply could be unknown or anything like that. Now, in case the break statement is not totally clear, again, when you're returning, you don't need it because that will quit code execution here anyways and will not go to the next lines. If you would not return anything, but do some calculation, update some other property, anything like that, then without break, another case could be entered as well. For example, the default case could be triggered as well, even though you already had this concrete case here. So to avoid such strange effects, you add break to make sure that no other case is considered in this switch case statement. Again, it's redundant if you're returning. So now we have complexity text here, and that will just be one of these strings there. And therefore now we can use complexity text as a text value down there. So simply output complexity text. And with that, if we save this, we also see the complexity text here. But now we also see a problem. These items sit way too close next to each other. Now a solution is to go to our row which holds all these items and add main axis alignment of main axis alignment, which, by the way, also is an enum built into Flutter, of course, dot space around, to use this enum value, because now the items are positioned such that empty space in the row, in that overall row below our image, is split up evenly. Side note, you now also see the bottom rounded corners because now the image is not overlapping them anymore. So with that, let's add our last item here, our last information item. And there I want to output the affordability of this meal. So a fitting icon could be attached money, which is this money symbol. And then for outputting a text here, we again need to transform our enum value into some human readable text. And therefore I will create another getter here, get affordability text, and basically do the same as in the complexity text getter. Take this switch statement, but now of course switch on the affordability, and then compare this to affordability.affordable, and maybe output affordable here. Then here we could have affordability.pricey, and output pricey down there, and also affordability.luxurious, and output expensive, maybe something like this. So of course the text you return doesn't have to match your label name. Also add a colon up here, and with that we can use the affordability text in that third information item here, like that. So this looks pretty nice to me. I'd say these are decent meals we're outputting here in our list. The next step is to go back to navigation and make them clickable, so that on a tab onto these items, we actually do go to the detail page for this meal, where we then see it full screen and we also see all the steps and ingredients. So back to navigation, we now need a new screen. We need the screen that shows the details about a single recipe. So in the screens folder, we can add a new file, and that could be the meal_detail screen.dart file. The meal detail screen.dart file will, unsurprisingly, display the details about a single meal. And just as before, I'll create a stateless widget in here, which I'll name meal detail screen. And as always, you know the game, we import material Dart from the Flutter package. And just to see something on the screen, I'll again use a center text here, where I say the meal, just to see whether we can navigate to that. So the meal detail screen should now be loaded when we tap on a meal item. So here in the select meal method, I want to go to that other screen. And you learned that for going there, we can use navigator of context and then push our new screen on top of the stack. Now it's up to you whether you want to use a named route and register it in the main Dart file, or if you want to use a route that you create here on the fly. I will go for a named route, so I will use push named here. But of course for that, we need to give this route a path, and I'll do this here with a static const property. I explained this earlier in the module. This is an approach that makes sure that we don't accidentally mistype our route identifier in one part of our application. And I'll give this a name of, what did I choose here? Route name. So I'll use route name as a name for this constant here too, just to be consistent regarding that naming. And then you can use any identifier you want, should be a string. And I'll use meal-detail here as an identifier, /meal detail. Let's now register this in main Dart by referring to the meal detail screen here, and there to the route name. For meal detail screen, for this class to be available here, you also need to import it. And my IDE added the import, but in not in the format I want to have it in. So I'll use the relative import here, pointing at the screens folder and the meal detail screen Dart file. And now here I use the route name as a key in this map of routes, and the value is this builder which gets the context and which should build the meal detail screen like this. So with the meal detail screen registered as a route here, in meal item, we should be able to go there. Now, first of all, we need the context here, so select meal should actually receive our build context. So when we register it here for on tab, we should actually use an anonymous function so that we can pass context as an argument to select meal. And then here for push named, we need to refer to the route name. So here we use the meal detail screen class, and for that you need to import it into this meal detail meal item Dart file too. Again, with the right import, going to the screens folder and then the meal detail screen Dart file. And with that import added, here I'm pushing to meal detail screen.route name because that's the identifier of this route. Of course, it would also be good to pass some data along, data about which meal was selected so that we know which meal to display on the meal detail screen. And for that, you learned that you can set the arguments key or argument parameter here on push named. And the argument here can be anything, can be a map, can be a string. Here I think it's enough if we forward the ID of the selected meal, because we can then fetch all the data for that meal on the meal detail screen. So we should expect to get the ID here in meal item. So ID is another property I want to get. I also added as a required property in the constructor therefore. And now in the place where we use meal item, which is of course in the category meals screen widget, we also have to provide the ID by accessing category meals for the given index and then ID and setting this as a value for the ID argument. Now the ID is available in the meal item, and therefore now we can use it as an argument here and simply forward that with push named. Inside of the meal detail screen, we can then get this argument just as you learned it before, here in the build method. There you can get your arguments or your meal ID, because this is the only argument we get here, with modal route of context, so connecting this to the context, settings, arguments. And again, this gives you the arguments object which is attached to the incoming route, to the incoming navigation. And in our case, since we set it here, that's only the ID, so that's only this string here. Hence, in meal detail screen, we can tell Dart that this will be a string in the end with the help of as string. And then maybe also output this down there with string interpolation so that we can see that this differs from meal to meal which we select. Let's give it a try. Let's click on the classic hamburgers now. And we load that we display this, but what is missing on this screen? Why do we have the output we have here? Because we are missing a scaffold. You learned that every widget which you use as a standalone page, which occupies the entire content of the page, so which you don't include just into other widgets, every standalone widget which you load through routing, which you navigate to with the navigator, needs a scaffold widget, because that adds the background, the app bar, and also in general connects the widget to our material app and to the theme set up there, to the fonts and so on. So we should return scaffold here, and our body will be this centered item. And besides the body, of course, I want to have an app bar where we can set a title. And for now, the title will just be the meal ID. We can later, of course, should be a text widget though, we can later, of course, use the meal title there instead of the ID, which is not that great for us humans. Now, if we go back, that looks way better. And if I select the salad, it has a different ID than the hamburgers, so passing the data also seems to work. And now we have a really nice navigation across multiple layers, where we can go forth multiple times and back multiple times, and where we're passing data around. The next step, of course, is to display more information about a selected meal. Before we do that, however, let's have a look at another feature Flutter offers you when it comes to loading pages. For loading pages, you learned that you can load pages with help of push or push named. When you use push named, you need to register the page, the route for that page in the main Dart file. When you use push, you create the route on the fly with the material page route class. Now, as I just said, for push named, you have to set up this routes table here in the main Dart file. And depending on the kind of app you're building, you could even have routes which you don't know in advance because they're generated in a dynamic way, so you can't set up a route name here, or you just want to have a fallback to be safe that if some strange navigation occurs, you can still show something on the screen. And for that, Flutter gives you two important methods here in main Dart. One is onGenerateRoute, which takes a function, and one is onUnknownRoute. Now, onGenerateRoute takes a function which gives you some route settings, so some information about the route, like the arguments, for example. And the function you pass to onGenerateRoute should also return a route. So here you should return a material page route, for example, where you then define a builder, which receives a context automatically, which returns the categories screen, let's say. Now, onGenerateRoute is reached, and therefore this function is executed if you're going to a named route with push named that is not registered in the routes table. So if I would comment out the meal details screen registration there, and I comment out on the unknown route to not get an error for the moment, then we should actually see that when we try to go to the meal detail screen, so when we click a meal here in the list of meals, we actually go to the categories screen, because here I defined that I want to load this route for any route that's not registered in the routes screen, as long as we try to reach it with through a named route. So if I now save this and I click on this item, indeed I'm back on the categories screen. And please note that I can go back now because I pushed this on top, because that's what I return here in onGenerateRoute. We don't need onGenerateRoute in this application we're building here, and in a lot of applications you might not need it. It's still important to learn about it, because onGenerateRoute, of course, gives you a lot of flexibility. It gives you access to the settings of the route, so you can find out which arguments this route has, but you can also find out which name you pushed to, for example. And then you can use this information. For example, you could check if settings.name is equal to /meal detail, and then return a certain material page route in that case. And if you have a different settings name, of course, you could also use a switch statement here. Then you could return a different material page route here. So that would be possible. And that, again, as I just said, can be useful in scenarios where you build highly dynamic applications, where you maybe have route names that are generated dynamically during the lifetime of your app, and hence you can't know them in advance when you're building the app, or anything like that. Then onGenerateRoute can be used in conjunction with push named and so on to still handle the names you're targeting, or still do something for these named routes and run your own logic that returns maybe always the same route or different routes depending on the route data. As I said, we don't need it here because, of course, we have no plans to comment out meal detail screen, and then this here is actually never reached. onUnknownRoute is also important. onUnknownRoute also takes a function, an anonymous function here, for example, which gets settings about the route it tried to load and which should return a route. So just as up there, maybe a material page route, which in the end builds the category screen. Now, onUnknownRoute is reached when Flutter failed to build a screen with all other measures. So when you defined nothing as a root route, when you defined nothing in the routes table overall, if you don't use onGenerateRoute, then in the end, as a last resort, before it throws an error, Flutter will try to use onUnknownRoute to show something on the screen. So providing some fallback here, either a generic starting page or some we couldn't find that page, error page, showing something here is a good idea to make sure that your users never end up in a state where the app just crashes, but that you instead always show something on the screen. So it's like your 404 fallback page in the web. If you enter a URL in the web which doesn't exist, most websites have a specific page they show to you where you see something like, oh, this page doesn't exist. Well, that is your fallback in a Flutter app here. So providing this is never a bad idea, and here I will provide it with categories screen as a default. So with this quick look at onGenerateRoute and onUnknownRoute, which can be useful depending on which app you're building, let's go back to this app we're building here. Let's make sure that for a selected meal, we show more details. This, of course, again, has no direct connection to navigation, but practicing to combine widgets with each other and build nice user interfaces certainly also isn't too bad, I guess. So let's go to the meal detail screen and now work on that. In there, instead of the centered widget, I want to have a column because we'll have a couple of pieces of information or a couple of different elements on top of each other. At the very top, for example, I want to display the image of the recipe. Then I also want to show the ingredients and then the steps it takes to, build this or to make this dish. Hence, at the very top, I'll first of all add a container which should hold the image, where I'll give this a height of 300 and a width of double infinity to be as broad as possible to basically span the full width of the device screen. And the child of that container will be the image. So here we can use image.network. And now we need to find out which meal the user selected. Keep in mind that we do extract the meal ID here. We can, of course, now use the meal ID to find the full meal here in our dummy data source. So in the meal detail screen, we can now import from that dummy data Dart file so that we have access to the dummy meals. And now we can get the selected meal here by having a look at all our meals, all our dummy meals stored in this dummy meals constant. And before we used where to filter a couple of fitting elements. Now we want to have only one fitting element. And for that we can use first where. This gives us one meal for which the condition in this function returns true. So again, this runs on every meal in the list. And when this function, this anonymous function returns true, it stops looking for more and gives us that item, that meal. And of course, the condition I want to check here with this shortcut syntax where I use the arrow function, where I don't need curly braces here, and the value of my expression here is immediately returned. I will compare meal ID to my meal ID up here. So meal.id, the ID for the meal we're looking at in dummy meals, compared to meal ID, this variable name here, which is the meal ID we got from our route arguments. Again, as I mentioned, this expression here, the value of that, so true or false, is immediately returned thanks to this shortcut here with the arrow function, and therefore we return true if the IDs match, and then we found our meal. So selected meal is the meal which the user picked, and therefore for the image down there, we can use selected meal image URL down there. Now on the image, I'll also set a fit to again fit it nicely into the surrounding container with box fit cover. Of course, you can also play around with different values here to see how the image is sized and cropped and squeezed differently based on the setting you choose here. With that, if you save it, you should see the image here already. Now, by the way, since we now have the selected meal, we can also show the title of the recipe here in the app bar. So instead of saying meal ID like this, let's add curly braces and use selected meal.title. The curly braces are required because we don't just refer to a single variable, but we have a little bit more complex expression. We use a dot notation here, and that only works with curly braces around it after the $sign. So now we're outputting the title and the image of the meal. Of course, that's by no means all. Besides the title and the image, I also want to show the ingredients of a meal. So after this container with the image, I'll add another container. And that container should hold some text where I simply say ingredients, basically as a caption for this, or as a title for the next list, which is a list of the available ingredients. Now that text should have a certain style, and that's a style we can probably set up globally in our theme. If we have a look at the theme, we have a title style already, and actually that is the style I want to use. So we can use that theme title style by referring to the theme here with auth context, and then text theme title, just like that. This will style this text nicely. If we save this, we see ingredients here. Now it would be nice to have some margin between the image and the text. So therefore here on the container, I'll add margin and set this to edge insets symmetric, and only target the vertical margin, so top and bottom, and set this to 10 maybe. Now we have some spacing between the title and the image, and this looks better in my opinion. Below that container, which really is just there so that we have a text, just a title for the upcoming list. So below that container here, I want to have a list of the various steps you have to execute. Now if I would add a list view like this here, we would run into a problem, because adding a list view, which by default has an infinite height, in a column, which also tries to get as much height as possible, would throw an error. So instead we have to use a container here, which has a fixed height, and then add a list view as a child of that container. The fixed height here is of course totally up to you. I'll use a height of, let's say, 200 here. And maybe also only a width of 300 here. And you could use a media query to adjust this to different device sizes. I'll not do it here, also to save some time, because that's not the main focus of this app. But of course you can refine these values by using a media query as you learned it in the responsive and adaptive apps module in this course. Here I'll just use 300, and if that doesn't really work on small, very small devices, it's okay for me here. Obviously, you can fine-tune it with media query. So we have a height and a width. Let's now add the list view as the child here. And that list view can be created with a builder or with this constructor and children. Ultimately, it's totally up to you. Theoretically, we don't know how many ingredients we have, and it could be very many. So I will use builder, which gives us better performance for very long lists. Here for builder, as you learned it, you need the item count, and the item count of course is selected meal, ingredients, length, because we want to output all the ingredients here. Besides the item count, we also need the item builder of course, and that gets the context created dynamically here for every list item, and then also the index of that list item, and we should return a widget here, and that widget for me will be a card, which I'll give a background color of our accent color. And that's just the style I want to use. As always, you can fine-tune this to your requirements and play around with the different values. And the child in the card will be a text, let's say. And that text, of course, should, for the ingredient with that index, output the name of that ingredient. And since ingredients for us is just a list of strings, the ingredient for a specific index is already the name of that ingredient. Let's save that. And this doesn't look too bad. Looks nice, but the problem I have with that is that if this would be smaller, let's say it has a height of 100, it would be not that obvious that you can scroll it, right? So the overall box here, the container which holds the list view, should probably have some decoration that clearly shows its boundaries and makes it more likely for the user to guess that you can scroll. So there, I'll add a box decoration and give this a color of white, so a white background color, and a border with border.all in all directions, which should be gray with colors gray. So this adds a border around the container. With the border argument in the box decoration object, we pass to the decoration argument of the container. And maybe also give that box rounded corners with border radius, and then border radius dot circular 10. Now let's also add some margin here with edge insets all of 10 around the entire container, and also some padding of edge insets all of 10. Whoops, that should be insets. And now every item here, so every card in the list view builder, also should have a little bit of padding inside of it, I'd say. So let's wrap the text, which is the content of the card, in another widget. And here we can just use the padding widget because I only want to add some padding. The padding here can be edge insets symmetric to have different padding for left and right and top and bottom of, let's say, vertical 5 and horizontal 10. And now we have some padding around the text inside of the ingredient as well. If we save that and we go back, this now looks better, and I think it's way clearer that you can scroll this. And I'll now increase the height to 150. That looks like a good solution. So now these are my ingredients here. The next part, which I want to output, of course, are the steps you need to follow to make this dish with these ingredients here. For that, I will repeat this title here. And since I will repeat it, we could move that into a separate widget, or at least move it into a builder method, and that's what I will do. I'll add a new method here to the meal detail screen widget, which I'll name build section title. The name is up to you. And I expect to get the text, you can name it title, text, whatever you want, as an input, as an argument. And I return this container, which in the end outputs this text here, which will now be dynamic, and which also needs the context. So let's also accept build context here. And now we can call build section title down there and pass in the context and the title, which here was ingredients, and do the very same below our container there, and do the same for steps, because then I also want to output the steps. And now we avoided code duplication and have also a leaner widget tree down there, thanks to that avoided code duplication. Now another piece which I want to replicate is this container with the list view. The list view itself will then work differently. There I will use different list items for the steps, but the surrounding container should be the same. So we can also move that into a builder method, and again creating a separate widget, maybe one which you store in the same file if you only use it here would also be fine. But I will add a builder method again, name this build container, and in there create my container with a certain child. That child is some input I expect to get, so that should be of type widget, and that's what I pass on to the container here, and then I can return it. And now the child is something we can pass in dynamically, so that we can now use the build container method down there to, well, build this container and pass child here as argument. Not a named argument though, but just like this. And of course you could turn it into a named argument as well. And now we have build container. We can now also use build container down there. And now my child, which I want to pass down there, will also still be a list view, with the builder method, but with a different list item in there. So it's not a perfect copy. Just as before, builder method takes an item count, and now we're talking about the steps it takes to create that meal. So for the selected meal, I now will have the steps length that define the count for this list view builder, because I want to output all the steps here. And therefore the item builder, as before, receives the context and the index. And again, we can use the arrow function shortcut here. We return the widget we want to build for every list item. And here I'll use list tile, not card, but list tile. And in the list tile, I'll set leading to a circle avatar. And we saw that before, if you remember, in our personal expenses app. And circle avatar will have a child, and that should be text, which is the number of this step. And we can derive that number based on the index, because the index starts at 0 and then counts up all the way to the length of the steps -1 because it starts at 0. So here we can output maybe hash and then string interpolation, use index +1 because it starts at 0, but we want to start at step 1, of course. To us humans, step 1 makes more sense than step 0, and output that here. So now we output the number of the step in a circle avatar at the beginning of our list tile. The title then is the step text. So here we have a text widget, which can be selected meal dot steps for the given index. And steps again is just a list of strings, so this already is the text I want to output. And with that, if we save this and reload, and we go to Italian, click on that, I'm getting an error, which has a cryptic error message, unfortunately, but which in the end is related to me not returning my container here in build container. Of course we have to return it here. We even state it here. Otherwise, build container here will, well, not render or not return a widget that can be rendered. So now this works, and now we have a different problem though. We go beyond the boundaries of our device. And you learned what we can do about that earlier. We can wrap our column, which we have here in the end, into a single child scroll view. So we can wrap this with a new widget, and that's the single child scroll view, which ensures that this column now is scrollable. And that's already it. Now we have that, and down there we have our steps, which are pretty nice to read and hopefully pretty clear. Now, as a tiny tweak, I also want to add a divider between these steps, and that can be achieved down there where we create these list tiles by not returning just a list tile, but actually a column, because I want to have two items on top of each other, where the list tile is the topmost item. But then, besides the list tile, or below the list tile, I use the divider widget, which is also built into Flutter. Whoops, should be here, however. And the divider widget will simply draw a horizontal line. So divider is provided by the Flutter framework, and it's added below the list tile. It's this tiny gray horizontal line you see here. So with that, I'd say this doesn't look too bad. It's a nice detailed page. Of course, you can tweak this to your likings, change the look if you want a different look. I think for this app, this is more than fine. But now with that, I of course also want to go back to more navigation features, because whilst we can go forth and back, which is nice, what we haven't really learned is how we can also use tabs or a side drawer, for example. And that's what we'll focus on next. So in this application, we can navigate around a bit, and we had a look at basic navigation, and as a nice side effect, we, I think, built a pretty nice app thus far. Now obviously you can tweak that app and continue working on that to really fine-tune it to your requirements, but I want to dive into more navigation-related features. And one such feature is that I want to have some tabs at the bottom here, which allow me to go to my favorited recipes, and right now we got no way of marking a meal as a recipe. We'll add that, of course. So to go to my favorites then, or to go to all these categories we got here. So for that, we want tabs, and I want tabs at the bottom of this category screen and also at the bottom of this to be added favorites screen. And actually the way you add tabs in Flutter works such that you add a totally new screen, and I'll name that tabs screen.dart. The name is up to you, of course. And that is a screen which will only manage the tabs and then load different screens depending on which tab was selected. So the tabs screen itself is a widget, though it will be a stateful widget here. And I'll name it tabs screen. And with this snippet, the Flutter extension gives me in Visual Studio Code, the widget and its state that belongs to it is created automatically. Now, as always, we need to import material Dart in here, and now we can start working with that. So the tab screen here is in the, whoops, should be tabs screen, by the way. So let's fix that in all these places. So the tabs screen here has the goal of rendering the tabs and then the appropriate content for each tab, depending on which tab was selected. So the tab screen will fill out the overall page in the end. And hence here in the build method, we should return a scaffold widget, because you learned if you want to manage the entire screen with a widget, you typically use a scaffold there, since this sets the background color, lets you add an app bar, and also, as you will now see, lets you add tabs. Now actually, there are two ways of adding tabs to Flutter apps, and I will show you both. The first way is that you add the tabs not at the bottom of the screen, but at the bottom of your app bar. And that's something you see in some of the Android apps that are out there. For that pattern, you actually don't return a scaffold here, but a default tab controller widget, which then has a scaffold widget as its child. Now, besides that scaffold child widget, the default tab controller also has a length argument where you define how many tabs you want to have. And I want to have two, one for all categories and one for the favorite items. Now in scaffold, you then add your app bar, and that is the normal app bar. And on that app bar, you can of course set your title, like meals, whatever you want. And you can then add a bottom argument to add that tabs element or that tabs bar at the bottom of this widget. And then inside of that bottom, you add the tab bar widget, which Flutter provides. The tab bar widget Flutter gives you here now takes a tabs argument, which is a list of widgets. In that list of widgets, you now add tab widgets. Again, these are all widgets provided by Flutter. And I will have two tabs here because that's the length I specified here, and well, that is the amount of tabs I need. So now here, each tab typically takes an icon which is displayed. And here we could go with icons.category, category for the category page. And you can also set a text here, and text actually takes a string, not a widget. And that could be categories. And here icon takes an icon widget, so we should wrap icons category with that. So that's the first tab. On the second tab, we also add an icon, which takes an icon widget, which then wraps icons dot, and then star is a good icon for indicating that this will manage some favorites here. And then we also add a text, and here we could have favorites as a text. So that's the second tab. Now the default tab controller and the tab bar here are automatically connected by Flutter behind the scenes to work together. So the default tab controller will automatically detect which tab you selected and then show the right content for that tab. You just need to tell it which content to show for which tab. And therefore to your scaffold, so after the app bar, you add your body, but now instead of adding a normal body like a column or a text, you add a tab bar view. And that's the last piece that's all connected together behind the scenes by Flutter. The tab bar view is taken into account by the default tab controller in conjunction with your tab bar, and Flutter then keeps track which tab you selected, and if it's the first tab, then the first element which you add here to tab bar view will be shown, and if it's the second tab, the second element will be shown. Because to tab bar view, you add children, and now you should add as many child widgets here as you have tabs, because then the child widget for each tab will be shown as the main body of this screen. And therefore here we could now add categories, the categories screen, and later also add the favorites screen, which we yet have to add. Now, first of all, let me fix the import for a categories screen here. I want to use a relative import and remove screens. We're already in that folder. And with that, add a new file, which I'll name favorites screen.dart. And for now, that will be a plain stateless widget, favorites screen, where you, as always, should import material Dart, of course, to unlock stateless widget and so on. And then, just as before, simply as a dummy here, I will show some centered text here, the favorites. And later, of course, we'll really populate that with favorites. Now, please note that I'm not using scaffold here, and I'm doing it on purpose here. And I'll show you why in a second. So back in the tab screen, we now use the favorites screen as the second widget here in our list of widgets. Now, both widgets should be instantiated, so you need concrete objects here. And now the default tab controller up there will automatically switch between them as you switch between these two tabs. And of course, the order of the tabs here should belong or should match the order of your screens here. First tab triggers or activates this screen. Second tab activates this screen. With that, let's load the tabs screen as our default screen. So in the main Dart file, instead of loading categories screen as the default, I now want to load tabs screen as the default. And of course, for that, you need to import the tabs screen. And you know me, I will of course adjust that path here to be a relative path. So now the tabs screen is loaded as a default. And if we now do a full restart here with that green arrow at the top, this is what we get. Now we have tabs here. And what you also now see is that we have a duplicate app bar for categories, but not for favorites. Now remember that for favorites I mentioned that I did deliberately not add a scaffold here. The reason for that is that now the favorites screen still kind of is like a screen. It still occupies the majority of our page, but it doesn't manage the entire page. Of course, we still have our tabs and the app bar of the tabs screen up there. So the content we load into a tab should now not bring its own scaffold because it will not control the entire page. Instead, it will be a part of the tabs screen. The favorite screen is now only controlling that bottom part here. So for the categories screen, you should now also get rid of the scaffold here and just return what you want to show in the content. So in my case here, the grid view. Of course, then also delete redundant parentheses at the bottom. With that change, now this looks better. Now you can of course configure these tabs. So here in the tab bar, you can control a bunch of things. A lot of that is never required, but you can change the color your tabs or the icons there will have when they are getting activated, which color your text in the tabs has, and so on. You can register a listener to any user tabs in case you also want to do something in that case. So you can configure a lot there, and of course simply play around with the tab bar to see what exactly you can control there. On the default tab controller, you can also, for example, set the initial index. And by default, that is 0, which means that the first tab is selected. But if you wanted to select the second one, the favorites one, then you would set this to index 1. And this index works like the index in a list. It starts at 0, not at 1. So now, with that, if I select 1 here as a default value and I do a full restart, you see we start with the favorites selected here. So that is all something you can do. Again, 0 is the default, it does need to be configured. And that is one way of adding tabs, in case you want that look where you have your tabs here sit right below your app bar. Now, for this approach of adding tabs, we of course wouldn't have needed a stateful widget here though. A stateless widget would have done the trick because we're not managing any state. That will change when we add tabs at the bottom because that simply works a bit different. Why? Well, simply because the Flutter team wants it to work like this. There you won't use the default tab controller. Instead, now we'll remove the default tab controller here and therefore return the scaffold in the tabs screen. That's where I am. Return the scaffold here. Remove the redundant parentheses, the closing parentheses. And now on that scaffold, if you want to have tabs at the bottom, you don't add them here on the app bar. So you get rid of that bottom argument here on the app bar where you added the tab bar. That's removed. And you also don't have a tab bar view as your body. Instead, let's ignore the body for now. I'll come back to that. Instead, you will add a bottom navigation bar. That's what a tab bar at the bottom is called. And for that, you have the bottom navigation bar widget, which you can add. Like this. It's also built into Flutter, and it adds a navigation bar at the bottom, as the name suggests. Now, this navigation bar needs some configuration to look good and to work correctly. For example, you can set the background color of the bottom navigation bar. And here I'll use my primary color for that. So primary color like this. Now, of course, you also want to add your items here. And items now are the tabs. So items now are bottom navigation bar items. And whilst the name sounds strange, that in the end is just a tab. Now, just as the tabs we had before, you typically have an icon there, which takes an icon widget, which then uses the icons collection here, so to say, to select the icon. And here I will use category. And you assign a title, which now is a widget and not plain text. But typically here you use a text widget, of course, to set the text you want to display on that tab. And here I'll have categories. Now, of course, we'll not just have one navigation bar item, but two. So let's add a second one. There I'll use the star icon and say favorites as a text. Now we have two bottom navigation bar items in our bottom navigation bar. And now comes the part that is the biggest difference compared to the tabs that we added at the top below our app bar. For the bottom navigation bar, you manually have to control what the user selected and which content you want to display. So for that, on the bottom navigation bar itself, you register a on tab listener, and that is triggered whenever an item is selected. Now on tab should execute a method, and I'll add a new method here. Of course, you could also use an anonymous function if you wanted to, but I'll use a method here which doesn't return anything, which I'll name select page underscore select page, because we're in a private class here. And select page here will receive the index automatically that's passed into this method by Flutter of the tab that was selected. So we now bind underscore select page to on tab, and that tells Flutter that select page should be executed when a tab is selected. And as I just said, Flutter will then automatically give you the index of the selected tab, so that you know if it was the first or the second or the third or whatever you have tab. Now you know what was selected, but now you need to control what's displayed. And for that, you should manage your own list of widgets which you want to render. So for that, I'll add a new property, a list of widgets up there. And I'll name that pages, underscore pages. You can name this whatever you want. And in there, I want to have the two, in my case, in this app here, two widgets which should be shown. And that's, of course, the categories screen, which I want to create here. And that's, of course, the favorites screen, which I want to create. And I just noticed that the import for the favorites screen is not in the format I wanted. So let me quickly fix that. Okay. So now we have that pages list here with the two pages I want to have. And we can set this to a final list, of course, because I'm not going to change that. And now one other piece of information is which page was selected, because this is basically giving us the data we want to use, but we also need to know which data to use. So I'll add another property, not a final one though, an integer, which is selected page index, which is 0 initially, let's say. And here in underscore select page in this method, I call set state. And now here, that's why we need a stateful widget, because we will manually switch that index and we want to update what's shown on the screen whenever that happens, because we want to switch the widget that is displayed. So here in set state, I'll set selected page index equal to the index I'm getting as an argument here. So equal to the index of the tab that was clicked. So with that, we can now use the pages and the selected page index here to display a content in our body. Because in the body, we can now use pages, and that's a list, and there we simply access the selected page index like that. And remember, pages is simply a list of widgets. instantiated widgets. So we do output our widget here then in the body, depending on which tab was selected. Let's give it a try and let's restart this application. And now we see one tab here. If I click on it, indeed we go to the favorites. And if I click on the left here, indeed I also see that other tab here. It's just having the same color as the background. So we'll have to do some styling, but in general, it works. In general, we can switch between our tabs here at the bottom. So let's now work on the styling. So on that bottom navigation bar, we set the background color for the overall bar. You can also set the unselected item color and set that to colors white, for example. If you do that and you restart the application, you indeed see that now favorites is at least a bit easier to see. But still, one problem we have is that when I select it, somehow it's not treated as selected. The other one does not get visible, and the selected item would be nice to see anyways. So back in our configuration, we can of course also add a color to the selected item with selected item color. And there I want to use my accent color that's set up in the theme. If I save this now, categories is a bit more visible because now we have that yellow look. Now still it would be nice if favorites would actually be marked as active when I click on it though. And for that you need to pass some additional information to the bottom navigation bar. Since you manage the selection manually, you manage the tabs manually, you need to feed that information, which tab is selected, back into the bottom navigation bar. And that's done by setting the current index. This tells the bottom navigation bar which tab is actually selected. So here I set this equal to selected page index, of course. And now with that, we can actually switch here and we do see changes. And you see you get a nice little effect here automatically where the font size also increases when you select the item. You can of course also control that effect here with selected font size and with unselected font size. Set these to equal and you will see no change in font size. One other effect you can add to these tabs here is you can set the type of that bottom navigation bar, and you can set this to bottom navigation bar type shifting. If you set that to shifting, you see the style changed, and now we have a nice animation here though. Now when you have a shifting bottom bar, you simply need to style a couple of other arguments, or with the help of a couple of other arguments, to get the same look we had before. When using type shifting, then you actually need to style your bar items on the bottom navigation bar item itself by giving that a background color, which now could be your primary color here. And of course do that on both bottom navigation bar items. And with that, they have their background color back because now every item needs to be styled separately. And with that, you can also use this shifting setup where you have no labels on the unselected item and only see them on the selected items here with that little effect. Now it depends on what you prefer. I'll not use shifting here. Instead, I'll either set it to fixed, but that's the default, so I'll just comment that out. And therefore just go with, the static approach here where we have these tabs. And that's the other way of adding tabs. Here we control the indexes on our own. What's the same as with the tabs in the app bar, however, is that the content we display here is essentially now just an embedded widget. I still call these widgets, the favorites screen and the categories screen, screens because they control the majority of the screen, the main content, but they don't control the entire screen anymore. For example, the app bar and the tab bar, of course, importantly, is now controlled by our tabs screen. Now, if you navigate here, of course, you still have the same behavior as before, though, but on that overview screen, you now have the tabs. To finish this off, let's make sure we also change the title up there, though, depending on which tab was selected. You can do that here in the tabs screen by simply tweaking our pages list a little bit. Instead of just storing a list of widgets, why don't we store a list of maps here, where we have string keys and then we have dynamic values, which means we don't know the exact type, or object values, which also basically means we don't know which kind of object. And therefore now here we have maps, where we have a page key that holds our widget, but where we also have a title key which holds the title we want to show in the app bar. And that could be categories here. And for the other widget, we also have page, of course, but then here we have title, and there we could say your favorites and close that, of course, as well. And now with that, we have our list of maps up there. And when we now select a page here in the body, we of course don't output the page's selected page index because that would be a map. But instead on that map, we access the page key because the page key is in our map what holds the widget. And we now can also use the title here in our app bar title. Instead of having the hard-coded meals here, we can use the pages property, access the selected page index, and then there the title key, which holds our string title. And with that, if we save this, and this restarts, we now have a setup where if you watch the title at the top, this title changes as I switch the tabs. So this is how you could also update the title dynamically. And of course, you can store any data you want in this map. So if you also would want to add some action buttons dynamically to the app bar, you could add a actions key here, which holds your list of widgets, which are all the flat buttons or whatever you want to add as action widgets in the app bar. So you can really add whatever you want here and then therefore load the data and use the data down there that you need to load and use based on the selected tab. Now, before we fill the favorites tab with live, which means that we'll have to write some logic for this app, I want to focus on adding a drawer, which is the other major navigation feature Flutter gives us, which we haven't had a look at yet. So let's add a drawer, and let's add it here on the tabs screen in this app bar here next to your favorite or categories, depending on which page we loaded. I want to have this hamburger icon which opens up a drawer. Now, thankfully, Flutter makes adding such a feature really, really simple. You add a drawer by simply going to your scaffold, not to the app bar, but to the scaffold, and there you can add a drawer argument. Now, the drawer argument typically takes a drawer widget, which is a widget built into Flutter, which automatically gives you a drawer with a nice backdrop. Backdrop is that thing that grays out the background behind the drawer and allows you to add content to that drawer. Now, on that drawer, you can add any content you want, any widgets you want. For example, to start really simple, I'll just add a child widget here where I say the drawer. Now let's see what this does if I add this simple drawer, just one line of code added. This line of code here gives us this hamburger icon automatically managed by Flutter, and if we tap it, this drawer slides open. You see the nice backdrop, this gray background, which you can tap to close the drawer, and you see behind the status bar at the top, the drawer text here. You can also close the drawer by swiping. So this is what you get out of the box with this drawer widget. And of course, typically you would not just add a boring text here, but a more meaningful content. Now, the content I do want to add here are essentially two buttons, two links, you could say, that take us to different pages in our app. One should always take us back here to this tabs screen, so to our meals section, and the other link should take us to the filters we can set to filter for vegan or vegetarian food. So these are the two links I want to have here. So let's add them to this drawer now. And since we'll add quite some content, I'll not add that here, but I'll actually create a new widget. Because you might remember, splitting your app into widgets is never a bad idea. So in the widgets folder, I'll add a new widget and I'll name it main_drawer. The name, as always, is up to you. And that will be a stateless widget here. In that stateless widget, which I'll also name main drawer, I want to handle or I want to compose the content for this drawer. So that means that I, of course, return a drawer widget here. And now the child of the drawer here as I mentioned, can be anything you want. You can build any content here into your drawer. I want to have a column in here because I want to have a couple of items on top of each other from top to bottom inside of that drawer. So let's add the children here. And as always, you can, of course, style this drawer however you want. I want to have a little container at the beginning, which has a height of 120 pixels and a width of double infinity, which means it takes all the space, all the width it can get, which has some padding, maybe of edge insets all 20. And again, I mentioned this over and over again, but these are always values you can play around with and you can style the way you want. I'll add an alignment. We have never done this before in the course. This controls how the child of the container is aligned inside of the container. And here I want to align the content with alignment dot center left to have it in the center but moved all the way to the left. So vertically it's in the center, horizontally it's on the left. Now that's my container. In the container I want to have a child, which should be a text widget, where I say cooking up. And of course, you could put any text in there. It's just some fancy text for our application here. And I'll style this text a little bit by providing my custom text style here, where I will set the font weight to, let's say, font weight W900. This picks a weight of 900. If you inspect your options here on the font weight, you see that there you have shortcuts like bold and normal, but you can also specify a concrete weight like weight 900. And if you remember, in the pubspec YAML file, we set up a weight 900 for Railway, which is our default font for the app, for this very thick Railway font. So I'm using that font style in the end here. Railway is the default font for the app, so I don't need to set the font family here. That's not required. I will set the font size, however, let's say to 30, and a color to theme of context primary color. And one other thing which I forgot up there, I want to add a background color to the overall container where I use my accent color. Can do this with the color argument on the container. By the way, an alternative always is decoration with box decoration where you then set the color. This does the same as the color argument. If you just want to set the color, there is no need to use this more complicated decoration approach. Only do that if you also want to set some other decoration like a border. If you do use decoration, however, you have to set the color also through decoration and not through the color key. Otherwise you would get an error by Flutter. Here I only want to set the color though, so there's no need to use the decoration. With that, we have no links in our drawer yet. So below that container, which basically creates a heading at the top of the drawer, let's now work on the concrete links on the buttons we can click. First of all, I'll add a sized box with a height of 20 to add some spacing between our header here and now the concrete content. And here you can, of course, again, add whatever you want. What looks particularly good in drawers, in my opinion, are list tiles. So I'll add a list tile here, and on that list tile, I'll set an icon at the beginning with the leading argument, with icons restaurant, which I think fits the meal theme pretty well, where I also will give this icon a size of 26. This basically works like a font size to make it a little bit bigger. And then add a title on the list tile, which holds a text widget where I say meals, and where I, of course, also want to add a style. So my own text style here, where in my case here, I want to set the font family to Roboto Condensed, like this. No typo there, hopefully. Set the font size to 24, a little bit smaller than the icon. And the font weight to font weight bold. Now, as a side note, W700 would be the same like font weight bold. So if you want that default bold style, however, you can, of course, just use that. Now, very important now, besides leading and title, I now also want to register tabs. And conveniently, the list tile has an on tab argument, where we can register a function that should be triggered when we tap here. And in here, I soon want to do something to go to a different page. Now let me copy that list tile here and create another one here with, not with the restaurant icon, but with the settings icon, which is this gear icon here. And then here I'll say filters or settings or whatever you want to use, same text style, and therefore yes, you could of course also use a builder method here. Why don't we do it since we learned it? Let's cut the list tile and add a new method here in the main drawer, which returns a widget, build list tile, which then simply returns our list tile here. And of course, we have a dynamic title, so that should be passed in as an argument, and the icon data should also be passed in. What you pass to an icon here, what's returned by icons, is of type icon data. As you can see, if you hover over icon, then you see that it needs icon data for its icon. So that's what I also expect to get here, because that's different for every list tile. And then here, instead of saying meals, I can use the title argument we're getting, and instead of using icons restaurant, I use the icon we're getting here. With that, we can use the build list tile method down there and pass in meals here for the first list tile, and then icons.restaurant, which gives us such icon data. And then do the same here for the second list tile. Delete all of that and instead call build list tile, where we have filters and use icons settings. Now, also important, I did mention this before, but it is important to keep in mind, instead of using a builder method, you could of course also put that into a separate widget which you use, and it might even be a widget which you only store in that same file. Normally, we have one file per widget, but if you have a widget which you only use in conjunction with this widget here, you could definitely store that extra widget in the same file. So using a widget instead of a builder method would be totally fine. Generally, there is no difference. That would change a little bit if in that widget you could potentially create here, you would maybe change some state or use the theme, so something which could trigger the build method of the surrounding widget. Then putting this into a separate widget would be good, because then only this widget's build method would be triggered and not this overall build method. Since here, however, we have nothing that could trigger the build method, we can also use a builder function. So that's just a tiny thing you could keep in mind if you wanted to optimize your app. For example, because I'm just talking about it, in the meal details screen widget, their build section title uses theme off, and therefore it could be an idea to put this into a separate widget. Again, as I said, maybe stored in the same file, so that only that widget's build method would be triggered if the theme changes. Now, it's of course important to keep in mind that in our app, however, the theme will never change. So for this app, that wouldn't matter. It wouldn't make a difference. And besides that, we're also using the theme here in our main build method anyways, so that would be triggered anyways. So it could be outsourced, but it wouldn't make a difference here. But let's go back to our drawer now, to our drawer widget. We have our build list tile method. We're building the list tiles here. Now I'd say it's of course time to also see something on the screen. And for that, let's use our main drawer here in the tabs screen on that drawer argument in the scaffold. So here, instead of creating a new drawer, I'll use main drawer, the custom widget we just worked on. And of course, for that to be available here, we need to import it with that import syntax. Go up one level, go into the widgets folder, and then import main drawer.dart. With that, we can assign the main drawer here. And now, if we go back to our app, we open the drawer, we should see this custom drawer, which in my opinion looks quite nice. And we can tap these items, but for now, of course, nothing's happening there. Let's change that in the next lectures. With the drawer added, let's now make sure we actually switch to different pages when we tap on these items here. For that, back in the main drawer, of course here, when we tap, I want to switch the page. Now what happens exactly upon tapping, of course, depends on which list tile we're on. So actually I expect a third argument here, which should be of type function, which is the tap handler, whatever you want to name it. So this should be a function we pass into build list tile, and that's what I assign here to onTap. So this is the function which should be triggered when this list tile gets tapped. And now, since this is an extra argument, we have to pass it to build list tile when we call it down there. So for the first list tile, I'll add an anonymous function, and for the second function, for the second list tile here, I'll do it as well. Now for meals, I want to go to my tabs screen here. Now this tabs screen also has a route name. Since it's our default route, it has just slash as an identifier. So here for restaurant, I want to go with navigator of context. I want to go to my slash route. For that, we can use push named and go to just slash, right? That's what we learned before. For filters, we need to add a new screen, which I'll do here. I'll name it filters screen. And there I'll add a stateless widget named filters screen. As always, imports material.dart. And then here, instead of having that container, I'll output my centered text filters. And of course, we'll add more meaningful content later. So the filters screen now also should have its own route name. So let's add a static const here, route name, as we have it on our other screens as well. And that could be /filters. And with that, we can register it in the main Dart file here in our routes table. We have the filters screen here. So this widget. And for that, we need to add an import here at the top, of course. So import./screens filters screen. So now we access filters screen here. I seem to have a typo here. Yes, this should be filters screen, of course, not filter screen. So now it's filters screen.route name. And then we have the builder function, which will build us a filters screen like that. So now it's registered in the route table. Now in the drawer, we can use it because here for the filters list tile, we can now use navigator of context, push named, and now use filters screen. And for that, import that screen here as well. So import from the screens folder, the filters screen file. So filters screen Dart is imported, and now down there, we can push filter screen route name. Now I'm not using that screen class.route name approach for our main route because I think just slash is hard to mistype. So here just using this hard-coded string should be fine. But of course you could implement this route name constant in the tab screen as well if you wanted to. So with that, we are able to go to different pages here. Let's see it in action. If I tap meals, here I'm in meals. If I go to filters, I'm on filters and I forgot the scaffold, but generally navigation works. Navigation works. Let's now also go to the filters screen and add a scaffold again so that we have our centered widget here on the body. And in the app bar, I have an app bar where I say your filters, something like that. And with that, that looks way better. And now we have a problem here. I have a back button here, and with that, I can go back to the previous page. Now maybe that's actually what you want. But I would like to have a hamburger icon up here so that I can open the same drawer which I have here. Now the solution is relatively simple. All we have to do is in the filters screen, we have to add the drawer again and reference our main drawer, and of course also add the import to that drawer here by going up one level and then to the widgets folder. And now we have that drawer icon here. But there's one behavior which I'm not liking. I'm always pushing my page, which I'm loading, on top of that stack of pages. We're not seeing it here because we have no back button in the top left corner, thanks to the drawer. But actually over time, we accumulate quite a big stack of pages because we never delete the page we're coming from. So we're not deleting the meals page or the tabs page here when I go to filters. But then if I go back to meals, I also haven't deleted filters and the previous categories page. So the problem is that we get a stack of pages that's bigger and bigger over time because we never clear the existing pages. Now that's no problem if we just go into a category, into a recipe, and then we have to go back at some time. So we will clear that stack at some point of time. And we want that forward-backward navigation there. But here for the drawer, just like for the tabs, I essentially don't want to have an infinitely growing stack. Instead, I want to clear my stack and simply push the new page as the only stack page here onto my stack, so to say. So if I go to meals, the filters page should be deleted. If I go to filters, the meals page, the tabs page here, should be deleted automatically. Now it's easy to do that in Flutter. Inside of the drawer, instead of using push named, you can use push replacement named. Or if you have no named route, but you create it in place, you also have push replacement, and then you would pass a material page route here. But for our named route, we have push replacement named. And the difference to push named without replacement is that now you will replace the existing page on the stack with the new page. So you don't add the new page on top of it in that stack of pages, but you replace the existing page. And hence you would also not get a back button. So with that, if I go to meals and filters, we have the same effect as before, but now we avoid that our stack gets bigger and bigger. And we can clearly see that effect if I temporarily comment out the drawer in my filters screen. If I do so, and I then full restart the app with the green arrow here, and I then go to filters here, you see now we have no back button here. And the reason for that is that Flutter recognizes that nothing is on the stack, that there are no pages to go back to, because we didn't keep the old page and push the new one on top of it. Instead, we replaced the old page, we deleted it, and then added the new page, and hence we can't go back. And this is sometimes what you want. Sometimes you don't want the user to go back, but instead you want to replace the existing page. For example, also when you add user authentication. When you entered your login data and you hit login, and you then reach your main app, typically you don't want to provide a back button to go back to the login because you already are logged in. That would be another scenario where you would typically use push replacement instead of just push. Well, and here with the drawer, it's just another example to avoid an infinitely growing stack of pages behind the scenes, which could lead to memory problems at some point of time. So we added our tabs and our drawers, but what we mostly did this far is we went forward. I showed you how to go to new pages, obviously because that is an important part. But sometimes you also need to go back programmatically, so not just through that back button, which is added automatically, but because something happened. And sometimes you also need to pass some data back to the previous page. Let's imagine here, when we're on the recipe detail page, we want to have a button that actually allows us to delete this recipe. Not permanently, but only such that we go back and in that list of recipes, we don't see it anymore. Maybe because we were in a list with a couple of recipes, we checked out this one, we didn't like it, and we want to go back, but we don't want to see this one for now. When we then go back and go back here, we would see it again. But temporarily, I want to get rid of it. Of course, that's a bit of a made-up use case, but it's a good use case for showing how you can go back manually in code and how you can pass data around. So for that, on the recipe detail or on the meal detail screen here, let's make sure that we have some button to go back and delete this recipe. And I think a floating action button is a good fit here. So I'll add a floating action button, a new floating action button widget therefore. And as a child, I'll just set an icon here, the delete icon, this trash bin here. And when we now press this button, so on press, that's the interesting part. There I want to go back. Now you can go back with the help of the navigator, and there not with push, but with pop. Now we also saw pop before in the course, and of course you need to use off context here, by the way. We saw pop before in the course to close our modal bottom sheet, for example. Pop removes screens that are on top of the stack, and things like dialogues or this modal bottom sheet are behind the scenes also managed as screens, only though they only make up a part of the overall device screen. But still they are treated as overlays to the current page and therefore can be popped off to remove them. And the same is true for entire screens like we have them here. So pop removes a screen. If I just call it like this, watch what happens when I click this floating action button. I'm taken back. That happens. So it's the same as if the user would press this back button here, or on Android, this back button down there. Pop can be very useful if you have something in your code that requires you to go back or to remove a dialog or some other overlay from the screen in code. Now besides pop here, you also have pop and push named, which does just what it says. It pops the current page off and thereafter it pushes a new named page. You also can check with can pop whether there actually is a page to pop. For example, if you navigated to a page with push replacement, then you replaced the existing page in the stack and therefore popping the new page wouldn't be possible because there would be no page to go to. Right? Because you replaced the existing page. So running can pop to check whether you actually can go back before you do call pop might be a good idea if you're not sure whether you have another page in your app. Here we of course can be sure, and therefore we can call pop like that. So this takes us back, but what if I now want to exclude that recipe we're coming from in my meals overview here after going back? For that we can also pass some data to pop. Passing data is optional, but here you can pass any data you want. A map, a list, a string, a number, an object, whatever you want. And here I want to pass my meal ID here. So down there I will forward meal ID, or backward, so to say, meal ID to the page we're coming from. Now on the page we're coming from, the question now of course is, how do I get that information? Well, the place where we pushed this page, this meal detail screen, is the meal item. There we have select meal, and there I have navigator off, push named. This push named method led to the meal detail screen being displayed. Now this push named method returns a so-called future. I mentioned futures earlier in the course already. Futures are objects that allow you to specify a function that should execute once they're done with a certain operation. And one such possible operation, in this case it is the operation at hand, is displaying the page you're going to. So meal detail screen is the page that is displayed when push named is done. Now once the user goes back from meal detail screen, push named is fully done with its operation, because then it has not just displayed that screen, but the screen is now also not needed anymore. So the future returned by push named lets you know once the page that you push to is not displayed anymore. So you can add then here to get that result this page you are coming from gives you. So if you're passing any result to the pop method, as we're doing it here, then you get that result here in the function you passed to then, and for now I'll just print it. And that's really important because whoops, no arrow here. That's really important because it's easy to think that this function here is executed once you reached the new page, right? Because you push a named page, and then once this pushing is done and once you see the page, this function executes. But that's wrong. Instead, you push a page, and when this page is popped, then this function here is executed, and then therefore you get the result that might have been passed to pop. So for now, I'm just printing that result. Let's see whether that works. If I go here to my spaghetti and I click this trash icon, we're popping. And indeed here I see M1, which was the ID of that meal. If I go to the spaghetti and I use this back button here, then I see null, because that still triggered this function. We did pop after all. Using the back button does nothing else than use navigator of context pop. But of course there no data is passed along. So now here we would have to find out whether we have a non-null value. And if we do, then I want to remove that meal from that list of meals that is displayed. The problem with that, of course, is that I'm here in the meal item. The solution can be that in the meal item, in the constructor, I get one extra argument, which is required. And I want to bind this to a variable, a property here, which is of type function. And that's the remove item function. And I bind to remove item here. And now I can call remove item down there if result is not null. So if result is not equal to null, then I know I have an ID of an item I want to remove, and then we can call remove item and forward result, which will be that ID. Now remove item is a function I expect to get in the meal item. So in the category meal screen where we set up that meal item widget, we now have to pass such a function. And that of course means we first of all have to create one. Now it's a stateless widget, which will be a problem because now I suddenly want to change its state. I want to change the meals which I display. So let's first of all convert this into a stateful widget with the refactoring tool here. And then here in the state class, we can add a new function which returns nothing, but which I'll name remove meal, where I expect to get a meal ID. And then here I want to update my meals and remove a meal with that ID from the list. For that, first of all, we have to make sure that we don't derive our meals here in the build method, but actually a bit earlier. And init state sounds like a great place for that. That's a perfect use case for init state, because when this page gets loaded, when that state gets created, then we want to load all meals that are based on the ID of the category we're getting. So all that code here for deriving our meals can be cut out of the build method and be moved here into init state. One important thing, however, is of course that I now need to add a couple of properties here. A string property category title, which is mutable, so which is not final, and a list of meals, which are my category or my displayed meals here. And for that, we need to import the meal model. So let's import meal.dart from the models folder. With these two properties added, here where I derive my category title, I do this without final so that we actually use this property and store the value there. And here for category meals, instead, here I'll set my displayed meals with the same logic as before. We don't need to call set state here because this will automatically run before build runs the first time. And now we'll load the data when this component or when this widget is created. And we can therefore now also manipulate our data and update the user interface because we're in a stateful widget now. So here with remove meal, I'll call set state. And I now want to remove an item from displayed meals. So I'll reach out to the displayed meals here and then use remove where, which will remove all items that fit or match a certain criteria. And that will get a function that runs on every item in displayed meals. And there I check if meal.id is equal to the meal ID I got. And if it's equal, then this item will be removed. Whoops, like this. It's in set state, so displayed meals will update, or it will update, but this will also update the view. And now here, instead of using category meals in all these places, we just use displayed meals. Now we can also forward a reference of remove meal of that function we added here to meal item. So there we have that remove item argument it expects, and there I pass a reference, a pointer at underscore remove meal. If we do a full restart, because we turned this into a stateful widget that typically requires a full restart, let's go here, and now we get a problem. The problem is that this call here, which I'm doing here with modal route off, is not liked in init state, because this taps into this behind the scenes context setup with the inherited widget and so on, all this behind the scenes wire up work. And this does not work here because context generally is, thankfully, a property that's globally available in our state object, but not inside of init state, because init state runs too early. It runs before our widget has been created or fully created, and before we have a context for our widget. So at this point of time, I can't retrieve my route data, unfortunately. Now, what's the solution for that, or how can we work around that? There is another lifecycle hook, which I haven't mentioned before, and that's did change dependencies. You don't use that often, but here it's really useful because this will be triggered essentially whenever the references of the state change, which also means it will be called when the widget that belongs to the state has been fully initialized and we can tap into context. This will still run before build runs. So in here, I can now put my code which I had in init state. Init state would have been great if we wouldn't have required to use modal route off context in here. So any off context stuff which you need to do in here will unfortunately not work. But in did change dependencies, it should work. So now if we do a full restart, this looks way better. And we go here into quick and easy. This looks better. And now if I delete this here, still there. Reason for that is that did change dependencies runs a couple of times after the initialization of that state. That's the difference to init state, of course. It runs whenever the dependencies of this state change, and that's also the case when the attached widget changes, which unfortunately is the case when we call set state here. So the state we set here, where we do delete a meal, is basically overwritten when did change dependencies runs again, and we basically load all meals again. A way around that is to simply leave a little mark that tells us that we are done initializing. So here we can add a bool, loaded init data, and initially that's false. Of course, therefore we don't have to use bool here, we can use var here. And here at the end, I will set loaded init data equal to true. And now here, before we run that code, I'll check if loaded init data is equal to false, or actually the shortcut for that, you could use that, but the shortcut is that you simply add an exclamation mark in front of this. So if this is false, if we haven't loaded the initial data yet, then I will run this code. So I'll move all of that, including my change here, to true inside of this if statement. And therefore, this code will now really only run for the first time. So with that, if we now do a full reload, we should have the behavior we want. This app reloads now. And then here, when we go to your recipe and we clear it, you see it's now gone from that list. If we do the same for Toast Hawaii, that's also gone. If I go back and then go again back to quick and easy, they are all back here, because once we click the back button here on our list of meals, this page is totally dumped and removed and the state object is cleared therefore, and hence the next time we click on a category and go back into the list of meals, a brand new page, a brand new widget, and a brand new state object is created, and therefore we again start with load init data set to false. So that whole load init data part and did change dependencies is a little bit of overhead we had to add here for this specific use case where we depend on the ID we get through modal route off context. The core takeaway, nonetheless, is that you can pass data around when you're popping by passing the data you want to pass back to the pop method, and then you can retrieve it with the then method on push named or push or whatever you used. And the function here runs not when you're done pushing, but when you're done with that page you pushed to. So when that page you pushed to is removed. That's really important. So a lot of work here, but I find it important to also understand how you can pass data back and use that data. And the additional knowledge of did change dependencies and how to initialize your data in a stateful widget, that also can't hurt. So now that we're passing data back and forth, let's populate our pages with more life. And let's start with the filters for that, so that we can set some filters here on the filters screen, which actually impact the meals we see here on the other screens. So that, for example, when I set my filter to vegetarian, I don't see the hamburger. Because if you check the dummy data, all these meals should be set up such that, for example, if we search for the hamburger there, the classic hamburger, it has the is vegan and is vegetarian flag set to false. So we should not see that if we have a filter to exclude non-vegetarian food. So let's go to the filters screen and work on it. As a first step, we can convert the filters screen to a stateful widget, because actually we'll have to manage which filters the user set or not. We'll also manage that globally in the main Dart file later, but we also need to manage it in this screen to update the values we show on the switches we're going to show on the screen. So here in my filters screen state, I'll start by initializing 4 Boolean properties: gluten-free, which initially is set to false, vegetarian, which initially is set to false, vegan, which initially is set to false, and also lactose-free, which is initially set to false. We'll need that data later on. Now let's go down to our body here, and in that body I think it makes sense to have a column, because we'll have multiple switches that should be shown above of each other. And therefore here, of course, we'll register a couple of children. As a first child, I'll add a container where I essentially want to set up some padding with edge insets all 20, and then add a child, which is just some text that tells us that we can adjust our meal selection here. So we say adjust your meal selection. We can also give this text some style, of course, and for that here, I'll here use my default title text theme here. So that's a container that simply displays a title. Below the title, I now want to have all these switches. And we can actually use a list view here. Since we're in a column, however, we can't add the list view like this. Instead, we would have to add a container, or what we can also do, we can take expanded. If you remember, that's a widget which will ensure that its child widget takes up as much space as it can get in the surrounding column or row. So it will take all the remaining space between container and, well, the end of the screen. So we can use expanded here and add our list view in there. And now, since I have a fixed amount of elements here, I'll not use the builder constructor, but the children argument here in the normal list view constructor. And now there is a specific list tile which we can use here, which looks really good. And that's the switch list tile. Again, that's built into Flutter. We haven't used that before. It works really well in a list and allows us to show a switch with some text next to it. The switch list tile requires a title, and I'll set the title here to a text widget where I say gluten-free. That's my first switch. Then we need to add a value. That is just as for the normal switch, which you already learned about, there to tell Flutter in which state this switch should be, because it doesn't manage that state internally. We have to manage that. Now that's why I added these booleans. We'll change these when the user clicks the switches, and we'll pass the data back into the switch then to update what's shown on the screen. So here I'll set the value to gluten-free, underscore gluten-free. We can also add a subtitle if we want to, with another text widget where we say only include gluten-free meals to make it really clear what this switch does. Now, of course, we also need an onChanged listener, so a function that executes when the user taps this switch. And there we get the new value, so the new value the switch should have after being tapped. And therefore in here we can now use set state, hence the stateful widget, where I set my gluten-free boolean equal to new value to reflect the change the user made here. If we save that, and we go to the filters page here, this is what we see, and I can now use that switch, which is pretty neat. Now, of course, we don't just have gluten-free meals, we have a couple of other switches. Now I'll repeat this list tile a couple of times, and therefore we can of course extract this into a separate widget or put it into a builder method. And I'll go for the good old builder method here, which returns a widget, build, underscore build, switch list tile sounds like a fitting name. Return the widget, and we need a couple of pieces of information in here. We need the title text, we need the description text for the subtitle basically, and we need to get a boolean value, which is the current value, and I want to get a function which updates the value, so update value, something like that. The title is then what I use here in my title text widget. The subtitle text widget here takes the description. Here for onChanged, I'll point at update value, and the value we pass to value here should be the current value. Now when we call build, underscore build switch list tile down there, we therefore have to pass all that information. So here that was gluten-free. Here I said only include gluten-free meals. Current value is our gluten-free boolean, and the update value function is what I cut out of my old switch list tile. So it's this function here, where we call set state and update gluten-free. So it's not much shorter, but a little bit. And now we can use that build switch list tile method and repeat it to also here build a switch tile for lactose-free to only include lactose-free meals. And of course, therefore, the current value we pass in is lactose-free, and set state should update the lactose-free value here. Then we add another list tile. Here we're talking about vegetarian food, so only include vegetarian meals. We pass the vegetarian boolean in as a current value, and that's also what we of course update when the user clicks the list tile. And then here, last but not least, we have the vegan list tile, only include such meals, and then here therefore we pass in the appropriate boolean property. If we save all of that and we go back, this is what we have, and now here we can set all these switches. Setting it here of course is nice. That should now also be reflected back into our meals. That means we have to wire up what we set here with what we output here in meals. Now, of course, there are different ways of approaching that. What we'll always have to do, though, is we'll have to manage our set filters in main Dart, because that is the only place where we can, in the end, reach both the filters screen and also reach the category meals screen, which is in the end where we need to pass our set filters. So I want to manage my filters globally in here. And in the state management module, as I already mentioned before, we'll learn about another approach that allows us to manage state that affects multiple pieces in the app in a global place that's not the main widget here, which always has the downside that the entire app will rebuild whenever we change state here, even though it might not affect the entire app. So here in my app, for the moment, however, I'll have to manage all my state, and therefore I'll convert this from a stateless widget into a stateful widget. just like that by using the refactoring tool. Now up there, I want to store which filters the user set. And I'll do this in a map with strings and Boolean values. I'll name that map filters and I'll set an initial value here. In the end, I have keys which are gluten, for example, and I'll set all these values to false initially. So that simply is my default setting for the filters as we start the app. Just like that. Now, of course, the goal is to update that map when the user sets the filters on the filters screen. Now, we could update this with every switch the user clicks there, so that if I click here, we automatically update our filters here in the main Dart file. That would be absolutely fine, but it's not the approach I want to use. Instead, I want to make sure that the user has to click a button on the filters screen, which then updates the filters here in the main Dart file. For that, let's add a new method here in my app state, which won't return anything, which I'll name setFilters. And there I also expect to get a map with string keys and Boolean values, which I'll name filterData. And as always, the name of that argument is totally up to you. Now that method should be called from inside the filters screen. Let's say it should be called when the user there clicks a button in the app bar. So in the filters screen widget, I'll add actions to the app bar, and I'll add an icon button there, where I set the icon to icons, to an icon where I use icons save, which is this save icon here. And when pressing this button, then I want to trigger this function which I'm just defining here in the main Dart file. Now passing that function here to the filters screen is pretty simple, because the filters screen is configured here in the routes table. So that's now an advantage of using named routes. When managing your state here in the main widget, in the main Dart file, then you have all your widgets that you load through routes be created here in that same widget, in that same file. So if you want to pass data there, like this property or this function here, so the setFilters function, or a pointer at that function, you can do that. Here to the filters screen constructor, I can pass a pointer at my setFilters function. And now that's passed into the filters screen and available there. So in the filters screen, I can now expect that. I can now expect a function, which I'll name saveFilters, which is set through the constructor. So let's add the constructor here, where I target this saveFilters. And now this function I'm passing in the main Dart file is forwarded here into the filters screen and is used there. And therefore now here, when pressing this button, I can refer to my widget, because the reference to that saveFilters function is stored in a property of my widget, not of the state. But you learned that you can reach out to your widget with the special widget property which Flutter gives you inside of your state objects, in your state classes. So here I can reach out to the widget and then simply call saveFilters and not add parentheses, but instead again just point at it and pass it as a pointer to unpressed. At least for now. That will soon change because I will need to pass some data to saveFilters, but for now that will do. Now back in main Dart, we now set up the connection between filters screen and the main app here, and we're able to call a method defined here in the my app state in the filters screen, which is pretty awesome. So now setFilters is callable, and later it will also get some data, and then I want to use that data to update my filters here. Therefore here we can now call setState, and in setState I want to override my existing filters, so this property up there, with the filter data I'm getting, because it will have the same format, it will be the exact same map. I will make sure that this is the case. If you want to be really sure, you don't use a map here, but a custom object, a model you create. I'll take the more quick and dirty way of using a map here, where you of course then have to make sure you're using the same keys. For an object, you would get auto-completion by your IDE and extra type checking by Dart, but for this scenario here, a map should do. And I'm then overriding my filters here with the filter data I get here. Now, of course, we also have to make sure that we now adjust the meals we present to the user based on the filter. Now at the moment, the meals that are available here in category meals are fetched directly from the dummy data Dart file. That has to change. Instead, I want to manage my available meals here in the main Dart file. So I'll add a list here, a list of meals, which I'll name available meals. And as a default, that should be dummy meals. And for that, of course, you need to add an import to the dummy data.dart file. And again, I'll adjust this import path to be /dummydata.dart. So now I import my meals here in the myapp state or in the main Dart file, and I use it here in the myapp state to initialize my available meals. Now meal is my model, which I also need to import here to be able to use it. It's in the models folder, meal.dart, and with that import added, this works. So when the app starts, my available meals is basically just a pointer at the meals I got here. Now when I set a filter, I want to change that. Then I want to set available meals equal to dummy meals, but now I use where to filter the dummy meals. And then I convert this back to a list. Now for filtering, we pass a function to where, which receives every single meal, and then has to return true if we want to keep it and false if we want to drop it. And now we have to go through all the filters we can set to decide whether a meal should be kept or not. Now we'll add that in a second. But first of all, let's make sure that we now use the available meals in our category meals screen. That means that again, down there where we set up the route for category meals, we can forward available meals. And in the category meals screen widget, we now just have to accept that. So here I'll add a new final property, which is a list of meals, which I'll name available meals, and then add the constructor, of course, and initialize available meals. And now use widget available meals down there instead of dummy meals. So instead of dummy meals, I just use widget available meals. And now the available meals are managed in the main Dart file, which is exactly how it should be, because there I can now filter them. Because that's also the place, the main Dart file, where my filters are managed. That's the global source of truth for the entire app. So we can get rid of the dummy data import now in the category meals screen. And now back in the main Dart file, we can work on the filtering logic. Up there. Now for filtering here, I simply want to check all my filters with if statements here. So I can check filters underscore filters, which is this property here, and check if gluten is true. So just this here is equal to equals true, right? So if you just have if filters gluten, that automatically compares it to true. If that is set to true, we know that we want to exclude meals that do have gluten in it. Now in our meal model, we see that we have is gluten-free, is lactose-free, is vegan, is vegetarian as properties. So if a filter is set for is gluten-free, we only want to include meals that are gluten-free. So we can add another condition here, and we check, is this filter set? And if yes, then the second part of this condition is also evaluated. Then we check, is the meal gluten-free? If it is not, hence the exclamation mark at the beginning, then I know that I don't want to include it, so we can return false. Remember that in this where method, or in the function we pass to where, we have to return false if we don't want to include a certain item in the newly generated list. And the newly generated list should respect all filters. Now, therefore, I check if a gluten filter is set, and if it is, then if the meal I'm looking at is not gluten-free, I know I certainly don't want to include it. I don't even have to check the other filters. It's not gluten-free. I'm filtering for gluten-free items. I don't need to include this one. And I'll repeat that same logic. So if I have a filter for lactose set, then if my meal is not lactose-free, hence the exclamation mark in front of this check, I want to exclude it. Same, of course, for vegan. If I'm filtering for vegan and my meal is not vegan, hence the exclamation mark, I want to exclude it. If I'm filtering for vegetarian here, and my meal is not vegetarian, hence the exclamation mark, I want to exclude it. That's my logic. If I make it past all these if checks, then I know either I'm satisfying all these filters or no filters are set, and therefore I will return true to keep the meal I'm looking at in my available meals. That was a lot of talking. Now we can finally wire it up, and for that we need to make sure that set filters receives a filter data map that looks like this map. So we can copy this map and go to the filters screen. And there I'm calling widget save filters. Now actually, of course, I want to do this in a way such that I forward the data I gather in here about which filters the user selected with the switches in this on this page. So I'll actually use an anonymous function here so that I can call widget save filters myself, like this. And I want to pass my data to that. So my selected filters, that's a map, and the values for each of these keys here, the values are of course the values I manage up there. So for gluten, I'll set this equal to gluten-free, what the user chose there, and the same for lactose-free, for vegan, and for vegetarian. And then it's this selected filters data, which I forward to save filters, which in the end triggers that set filters method here in my app state. Let's give that a try. Let's save that all and do a full restart with the green arrow. And as a default, no filters are set. And let's now set vegetarian as a filter and hit save here. Don't forget that, you need to save. And then go to meals, quick and easy. And indeed, you might remember that previously we had a burger in here, and the burger is not included anymore. Now what we're not doing at the moment is, if I go back to filters, I don't reflect my currently set filters here. So let's do that as a next step to finish up that filtering logic. Of course, it would be nice to see which filters we set here on the filters screen, and therefore we have to make sure that we don't always initialize these with false values, but actually with the values that are set here in the main Dart file in my app state. So that means that I simply want to forward my filters here, my current filters, to the filters screen. So besides a pointer at the set filters method, I'll also forward the current filters. And in the filters screen, we can therefore get that data. So here we'll get a map with string keys and bool values, the current filters, that sounds like a fitting name, and that will be the first argument I get here, the current filters. And now here, we should actually not initialize this with false, or at least not keep it set at false. Instead, we can now use init state to really set our own initial state when this state gets created, with add override, and important with super.init state. And now in here, we can override these values based on the values we get in our widget current filters map. And there for gluten, I'll set my gluten-free value. Now we can repeat that for lactose-free, access the lactose key on the current filters map we're getting. For vegetarian, access the vegetarian key. And for vegan, access the vegan key. And now when this state is created, which happens when this page is loaded, we initialize our values here and therefore also our switches to match our currently set filters. So back in the app here, I restarted it completely. Let me now again filter for vegetarian meals and save this, never forget that. Go to meals, quick and easy. The burger is not there. Now let's go back to filters here, and we see that's also still saved. Let's now also filter for gluten-free meals and save this, go back to meals, and now the spaghetti are also gone, as they should. So this should now all be working. And if we clear our filters here and save that, of course, our recipes are back. So that's looking pretty sweet. Filtering works. Let's now work on the favorites. So time to work on the favorites feature. Let's start with the favorites screen. On the favorites screen, thus far I only say the favorites. It's not bad, but maybe we want to show some more meaningful text if we have no favorites. Like, you have no favorites yet. Start adding some. But of course, we also want to allow the user to add some and then also output the favorites here. For that, the first question is, how do we save, or where do we save which items, which meals the user marked as favorites? We could add a new field in our dummy data, and therefore in the meal model here, where we have something like a bool is favorite, which can be edited. We could do that, but it's a bit unrealistic. In reality, we would probably fetch some data from a server, and if we store the "this is our favorite" data directly on the meal, then this would not be scoped to our user. Instead, every user that fetches the data from the server would now have this as a favorite. So storing this on the meal itself might not be perfect. We could do it here, of course, for this dummy app, but I'd rather use a different approach. In the main Dart file here, where we manage our filters, I also want to manage a list of favorites. That's the approach I prefer. So there we have our list of meals, which are the available meals. I want to have a second list of meals, which are our favorited meals. Now, by default, that's an empty list, because at the beginning we have no favorite meals. Favorite meals. So by default, we have no favorite meals, but now I can forward these favorite meals here to our favorites screen. The problem with that, of course, is that the favorites screen is not part of our route registration here. Well, but it's part of our tabs screen, right? In the tabs screen, we get access to the favorites screen. So we can simply forward favorite meals to the tabs screen, and in the tabs screen here, we now can accept this as an input. So here we get our list of meals, and the name here is favorite meals, and meal is the model which we have to import by going to the models folder and then pointing at the meal Dart file. And of course we add the constructor here to save our favorite meals. So now we have the favorite meals in the tabs screen, and there we can forward them to the favorites screen, which we are creating here. So we can go to favorites screen and now forward widget.favoritemeals. So now in the favorites screen, we can also accept that. And again, in the state management module, we'll learn a different way of managing and passing our data around so that we don't have to go through multiple layers of widgets and pass our data through constructors. But for the moment, it is what it is. So here we also have a list of meals in the favorites screen. Therefore, we import our meal model from the models folder. And I will name this favorite meals here as well. Of course, you could pick a different name. And favorites screen receives these favorite meals as an input, so as an argument here in the constructor. Now we can work with the favorite meals here. However, we'll have a problem in the tab screen. Widget is not available here when we initialize our properties. You can use the widget property in the build method, you can use it in init state, but you can't use it here when you initialize these properties. It's a problem that's easy to solve, however. Since we're in a stateful widget, and therefore in the state object here, we can simply add init state here, the init state method, and do our initialization of pages in there. So cut that code here and create this in a non-final way. And then here in init state, set pages equal to that list, because here in init state widget is available. It will still run before build executes, so we'll have no problem there with that screen not being loadable or anything like that. So we will have everything set up when build runs, but we avoid that issue of widget of that property not being available at the point of time we're initializing this class. And in general, by the way, when you're initializing a class in this property, you can't refer to any other property. So for example, I couldn't set this equal to pages here either. You can't refer to other properties because the creation of the class isn't fully finished. That's also why we can't refer to the widget property. So with that, however, by using init state, this should all work. And now we can forward our favorite meals from the main file to the tabs screen, and from the tabs screen to the favorites screen. Now in the main Dart file, we only need to add some logic to add or remove meals to and from the favorites. That logic for adding and removing favorites should be managed in the new method here in the main Dart file in our myAppState class. The method will not return anything, and I'll name it toggle favorite. Now here I expect to get the ID of the meal, which is a string, that should be turned into a favorite or unfavorited. And with that information received, the goal now is to add it to this favorite meals list. However, of course, only add it if it's not already part of that list, because if it already is part of that list, then I want to remove that meal, because it's a toggle method that should either add or remove. We can do this with favorite meals and then index where. This checks whether a certain element is part of that list and then automatically gives us the index of that meal if it is part. If it's not part, the index will simply be -1. So I'll store this in a final variable, existing index. And here, as so often, you pass a function which receives the meal, so which runs on every element on the list you're running index where on, and this should return true or false. So I will compare the meal ID with the meal ID I'm getting. And if I find a meal in favorite meals where this condition is met, then I know that then I will get the index of that meal in the favorite meals list, and I need that index to then remove it there, because if a meal with that ID is already part of favorite meals, then I want to remove it because it's a toggle method. If I don't find a meal, then existing index will be -1, and I know that I have to add that meal. So now here, I'll check if existing index is greater or equal than 0, because if it's -1, then I didn't find anything. If it's greater or equal than 0, then I know that I did find a meal. And therefore, if it is greater, then I want to remove a meal. So I will call setState here. And in that function we pass to setState, I'll call favorite meals and use remove at, which takes the index of the element I want to remove. And that's my existing index. So this will now remove the element at that index from the favorite meals list. And since it's in its state, it will rebuild, therefore rebuild the material app with the routes table and pass an updated favorite meals list to tabs screen, because that's all rebuilt. Now else, if I didn't find the element, then I will also use setState, and I will then use favorite meals add to add an element. And there I want to reach out to my dummy meals or to the available meals, but I will use dummy meals so that filtering doesn't play a role, because you should also be able to toggle recipes which are not matching your filters. So here I'll use dummy meals and then first where to find the first element, the first meal in our data source, in our meal source, which has the same ID, with that good old function we passed there where we get the meal, and where I then simply return meal ID equals meal ID. So that gives me the meal with the same ID in our data source. The first meal I find with that ID is then added to favorite meals. Now again, that of course means that whenever I toggle a meal as a favorite or turn it into a non-favorite, then this build method is called, and therefore the entire app is rebuilt. Now, this is of course not optimal, as you can imagine, because switching the favorite status of a meal should not necessarily impact the entire app. And therefore, this is the number one topic we'll toggle after this course section once we dive into state management, because for bigger apps, you definitely need a more elegant way. For the moment, this is fine, but it is definitely something we'll improve later in the next course section. So for the moment, it's fine that we rebuild everything though, and we just need to make sure that toggle favorite actually reaches the detail page of a meal, because there I want to be able to toggle the favorite status. In the meal detail screen widget, instead of having that floating action button, which deletes this meal, which was just a demo for showing you how you can pop data and so on, instead of having this, I want to use this floating action button to let the user favorite or unfavorite a meal. So on this floating action button here, when this gets pressed, I want to call this toggle favorite function here in main Dart, this method. Hence, we should pass a reference to this method down to the meal detail screen here in the constructor in our routes table. And now in the meal detail screen there, I just need to accept this. So I'll add a new property here, a function, toggle favorite seems to be a fitting name. Of course, you can pick any name you want. And now add the constructor and bind the data, the argument we're getting, to that property. And then we can use toggle favorite down there on the floating action button when this is pressed, and simply use the reference to the function here without parentheses so that the function gets executed when the user presses the button. Now, of course, we can also find a better icon, and the icon should also reflect whether this currently is a favorite or not. And for that, I'll add another method in main, because main has the information about which items are favorites and which not. There, I'll add another function, another method in the main Dart file, in the myAppState class here. Another method which will return a boolean, which I'll name isMealFavorite, because it will check if a meal is a favorite or not. It receives the ID of a meal. And then here I want to return true if that ID is part of my favorite meals list. So we can check if favorite meals, and now there's a any method which you can use on lists. So you're learning a lot about list methods here in this course too. So there is a any method which you can use on any Dart list that also, as so often, takes a function which it runs on every list element. And here I want to return meal.id equals ID. And what I'm doing here is I'm checking if the meal I'm looking at, because this function runs for every meal, has the ID I'm checking. I'm checking if that meal with that ID here is a favorite. So I'm running this function on every meal I have in favorite meals. And any returns true if I find any element in here where this is true, and it will stop after the first element it found. So it will essentially give me true if I have a meal in favorite meals which has the ID I get here in isMealFavorite. And now I will pass this method here, a reference, a pointer at this method, to the meal detail screen as well, as a second argument. And in the meal detail screen, we therefore now can also store this in a property. Final function, which I'll also name is favorite maybe. I get this here as a second argument, is favorite. And now we can call is favorite to find out whether this meal we're currently looking at is a favorite or not. We can do that here in the floating action button to show a different icon based on whether it is a favorite or not. We can call isFavorite, and we just have to forward the ID of the meal we're looking at. Now that ID is something we have because we're extracting it here into meal ID based on the data we're getting when this route is loaded. We're getting this with the modal route of context approach. So meal ID is a variable we create here in build, which has the ID of the meal we're looking at. So I pass meal ID to is favorite, and this will return true if the meal is a favorite and return false otherwise. Now if it returns true, and I'll use a ternary expression here, then the icon I want to render here should use the star icon, which is that filled star. Otherwise, I want to use the star border icon, which is the empty star, so that when this is a favorite, we see the filled star. If it's not a favorite yet, we see the empty star. And when we tap this, this will of course change, because then we'll add this meal to our favorites thanks to toggle favorite, which is linked to that method here in the main Dart file, to that toggle favorite method there. So that was a long story. With that, we're not yet outputting our favorites on the favorites screen though. So on the favorites screen, to output that, we first of all need to check if we have favorites. So here I'll check if favorite meals, so if this property, which is a list of favorites we're getting, if it is empty, we can do this with the isEmpty property, which Flutter or which Dart gives us automatically on every list. And if it is empty, then I want to return this centered text here in the end. Else, I'll return something else in my build method. I'll return a list of meals. So then I want to return basically the same list I have here in the category meals screen. There we have that list view builder function call. I'll just copy that because that's exactly what I want to return here in the favorites screen. Of course, meal item is a widget I need to import in order to use it here. So I'll import from the widgets folder meal item Dart. And now we have to pass in that data. And of course, instead of displayed meals, that is favorite meals. So here I'll use favorite meals in all these places down there, favorite meals index in all these places. And when we remove our item, well, that's not required anymore simply. We can get rid of that. I only had this in there temporarily to show you how to pass data back. We don't need it anymore. We can also get rid of that remove item thing here in the category meal screen. And of course, now also go to the meal item and not expect this anymore. So there on the constructor, we shouldn't expect this remove item thing here anymore. So let's remove that argument here and remove that final property. And of course, comment this out. We don't need that anymore. With that, connection here crashed. Let me restart the app here. And we should now have a setup where we hopefully are able to mark our meals as favorites and see them in the favorites tab. And then also, of course, switch them back to not being a favorite if we want to. So let's wait for this to finish and let's then see it in action. So here I am. If I go to favorites, I see you have no favorites yet, which makes sense. If I now go here to quick and easy, then I get an error if I try to see the detail page. And the problem I have is actually, if you have a look at the error message, that type string void is not a subtype of type empty to void. So this means somewhere we have a function where either we passed a string as an argument and it expected no argument, or it expected a string as an argument and we passed nothing. It has to be one of the two things. And we do. Toggle favorite. Here in meal detail, I am pointing at toggle favorite, and this is coming from the main Dart file. And their toggle favorite indeed expects to get my ID, which is a string. So just pointing at it as I'm doing it here will not work. Instead, we have to pass in a concrete value here. So we will wrap this in an anonymous function. And then here I want to forward my meal ID, of course, because we need that in order to set the ID, to toggle this as a favorite. So with that, let's restart it. And now if I go to quick and easy, toast Hawaii, now I can load this page. And now let me click that empty star. It's empty because it's not a favorite yet. And now it's filled out. And let me do the same for maybe, let's say here, for the delicious orange mousse. Also a favorite now. And let's go back and now to the Favorites tab. And there we see these two items. And now I can, of course, also go there and, well, make this a non-favorite, the delicious orange mousse. And if I go back, still part of that screen though. Now if I go to categories and back to favorites, now it's gone. So why are items still a part of the favorites screen if I mark them as non-favorites when I then go back? That's happening because when you have an item here in favorites, like this schnitzel, and you then go into the detail page, and you now uncheck this as a favorite. If you now go back, you go back to basically a cached version of that page. This was not reached by the rebuild of the Flutter app, so to say, because it was cached away. Only if you go to a different page and then come back, Flutter recreates that page and now updates this based on the most recent state where this indeed isn't a favorite anymore. Now, what can we do to avoid showing outdated data on our favorites screen, therefore? For the moment, this is the way it is, and there's no super simple or clean way of solving this. However, it will be super clean and easy to solve once we have learned more about state management, which will generally help us with managing global data like we're managing it here in our main Dart file. When we use the main Dart file for managing that, we run into problems like this, and we also have the problem of always rebuilding the entire app with every change. These are all problems that will be solved with a better state management tool, which is why we'll have a look at such a tool in the next course section. Dirty fixes, which you could apply right now, would, for example, be that you turn your favorites screen into a stateful widget. You handle the pushing of a meal item here in that favorites screen widget instead of the meal item widget. So you would have to have a function here and pass a handle to that function to meal item. And then with the then listener on your push or push named call, you could run some code when that recipe detail page we're on, that meal detail page, is popped off. And in that code you then run, since this would be a stateful widget here, you could call setState with no content in it to force an update of this screen. But this would be a really dirty workaround, which is why I won't cover it here. Instead, we'll learn about a way cleaner approach in the next section. This section here, however, now is done, and you learned a lot about navigation, passing data back and forth, and, as a side note, about building a beautiful application. So we're done with this module. A long module, but we built an entire app. And I hope you learned a lot about Flutter, about a couple of widgets which we haven't used thus far, and most importantly, of course, about navigation and passing data back and forth. There, we added a lot of features. And you learned all about the core basics there, like what screens or routes pages, these are all just different terms for the same things, are that they are just widgets in the end, but widgets which you use to control the entire page or at least a significant part of it. That the Flutter Navigator allows you to switch between these pages with push, pop, and replace. That you can use named routes or unnamed routes. And of course that you can also pass data between these routes. You can pass them as arguments, either directly as an argument to the constructor if you're using non-named routes, or via the argument key when using named routes. You can also pass data back and read via a future, as you learned. And the data, that's really important, can be anything. Strings, ints, objects, whatever you need to pass around. We also use tabs here. And you learned that you can add tabs in different ways, at the bottom of the app bar or at the bottom of the page. And the tabs in the end allow you to switch between different stacks. So there you can't really pop. The same thing was true for loading a page through the drawer, because instead of pushing a page, you simply go there as an alternative to the current page by clicking a tab. We also had a look at drawers, and I spent some words on dialogues and how you can control those with the Flutter Navigator. Drawers are just side menus which you can open, and there again you switch between different stacks, at least if you use push replacement. And drawers, just like dialogues, can also be closed with Navigator pop. We didn't really use this in this module, but we used it earlier in the course. In our personal expenses app, there I called Navigator off context pop once we submitted data in our modal bottom sheet to then dismiss this sheet. So pop is not just used to go back from an existing page you're on, but it can also be used to close a modal, like a modal bottom sheet which you opened, an alert dialog, or any other overlay you can put onto your screen with Flutter's help. With that, I hope you learned a lot about navigation and of course about Flutter, and in the next section we'll tackle the issue of state management, which you probably already got a feeling for that this is kind of a problem, especially in bigger apps.